Welcome back to my channel, as on African Motives. Still working on O-level mathematics in this platform. We shall be focusing on the question paper which was written in November 2015. That's the November 2015 session, and as you can see, paper 2. So we just want to focus on the revisions of paper 2. So we shall try by all means to finish up this question paper, guys, that we are given. So let us quickly see what we have got here. Remember, you're supposed to read everything, guys, your instructions. The ones that you're given, make sure that you read your instructions, okay? The instructions to the candidates, everything, make sure that you have got. And also, the most important part, this is paper 2, so I just want to talk about this part before we move on. We didn't have this part in paper 1 here on the answers which are in degrees, because remember in paper 1 you can't determine anything in degrees, because like from your angles, this can be only be in paper 2, since we now have the access of arc sine, whatever that you're going to have, or arc cos. So now if those angles are there, make sure that you're going to round them to 1 decimal place. So this part is very, very important when dealing with angles. Okay, so that's it. And also the other part, the decimal part, this one we had it from our paper 1, so we're now used to this one, the 3 significant part, 3 significant figure. This one we are now used to it. So we shall just quickly rush through and see what we've got here. So that's what we had on the first part. Let's see. Okay, the first questions we are given to find the value of, this is what we are given, guys, to simplify. All right, so what are we supposed to have or to do in this case? This is evaluate, find the value of, that is to evaluate or to simplify. If I have to cross-check here, we are given this part is a mixed fraction, so let's just have it as an improper fraction. We know that we're going to multiply here, then we add. Okay, so it's 4 times 1, which is 4, plus 3, which is going to give us 7 over 4. So we're going to have 7 over 4 in this case, plus if we multiply here, we do the same. We are going to multiply these two. All right, then we add to this part. So we're going to multiply, then we add to this one. So it's going to be 6 plus 1, which is 7 again. So this one is going to give us 7 over 3. Okay, so it's plus 7 over 3 like this. Okay, so let us close our bracket. This is a division. So take note, guys, this part, I want you to see the difference between this sign here that I'm indicating and this one. This is a division, or if we are to cross-check better, you're going to see that it's actually a division part that we are having. So let me just try to increase this part. All right, I don't know why we are having this part here, guys. Okay, but I'm just gonna try to increase. Okay, here a little bit like this. Yeah, that's a division there. You can see the 2 dots here. You can see the 2 dots, which we are not having on this one. So we just have to take note of this one. Okay, so I was just trying to indicate or to clearly show to you guys what is happening. Okay, so that's a division here. I don't know how you saw it, but I saw this one as a division. So it's 5 over 6. That is what we have. Then we go to our BODMAS concept. Remember our BODMAS concept here. All right, we have got brackets of division. So we have to start with the brackets first. What are we having in the brackets? We are adding. So we are going to add these two. That is find the LCM of this part that we are given. So we're going to find the LCM here of 4 and 3, which is going to give us 12. All right, so it's 4 into 12, that is 12 divided by 4, which is 3. Then whatever that we get, we multiply to this 7. So 3 times 7, that is 21, plus we do the same, 12 divided by 3, which is 4. 4 times 7, which is 28. Okay, so that's what you're going to have. And if we are to add these two, we obtain a certain answer. Okay, so let's see what you're going to obtain. 28 plus 21 is going to give us something like 49. This is paper 2, guys. Use your calculator, you can add. That's 49 over 12. Then we can now introduce the multiplication here. Since we are dividing, we can introduce our multiplication. So this is going to be times. Remember, the moment you introduce your multiplication, you invert your second fraction. So that is going to give us 6 over 5. So that's what you're going to have at the end. All right, so let's try to reduce this part by 6 here. That is 1. By 6 here, that is 2. Then we can multiply, since we cannot reduce anything here, we can multiply numerator by numerator. That is 49 times 1. That is 49 over 2 times 5, which is going to give us 10. All right, so that's it. We can simplify further. That is 10 into 49 is going to be 4 times into 40, and we've got remainder of 9 over 10. So that's it for you guys to obtain 3 marks. So that was the question we are just given to evaluate or to simplify this part. Okay, so let's move on to the second part that we are given in this case. Okay, so I'm just going to just a little bit. We're asked to factorize completely. So take note, we are factorizing completely here. So remember guys, on your factorization, I told you guys when the coefficient here is a 1, you can simply have your 2 brackets direct here. Okay, so you've got y here and y here, and you focus with this constant, which is minus 24. So we need factors of negative 24 that we are going to add to obtain the middle number here, which is a 10. So which factors are we having in this case? So I've got these ones, 12 and negative 2. So you can just try. There are so many factors that when you multiply, you get negative 12, negative 24. Like you can multiply 2 and negative 12 like this. You can multiply 6 and negative 4. It can be negative 6 and 4. There are so many. But which one are we going to add and obtain the middle term, which is 10 in this case? We're going to see we have got this part. If you add these two, we are going to obtain 10. So these are the numbers that we need. So we've got a plus 12 here and a negative 2. We're done. That's 2 marks for you. Or you can use the longer way. Remember, for the longer way, it's fine if you want to do that, but as guys use simple methods. Okay, factorize completely again on item 2. We asked to factorize. So what we have here that is common, we do not have here. Okay, on x we do not have, but on the numbers we've got 3 here on 27 and 3. So 3 is common. You can factor out 3. 27 divide. So you divide 27 divide by 3, and this gives us what? A 9. So that's a 9 here. Then here it's minus 3x squared divided by 3. So it's negative 3x squared like this, divide by 3. This cancels, you're left with negative x squared. So what you factor out is the one that you use to divide each term. Okay, so that's the concept. And at this stage, if you are to cross-check, we can see that this is a difference of 2 squares. Why? Because I can write this 9 here as 3 squared. Okay, we know that 3 squared is equivalent to 9. So that means we can have 3 into 3 squared minus x squared. Okay, why writing this format? We are going to have these numbers which are raised to the power of 2 into the brackets. And one of the brackets, remember I told you guys, is going to add, and another bracket is going to subtract. Okay, so that's what you're going to have at the end. 3 into 3 plus x, 3 minus x. So what you simply need, guys, is to understand the concept that you're given. All right, so that's it, guys. We've got 2 marks here. Let's see the other part. Do we still have anything here? All right, we do not have. Let's go to the next page. All right, this is a function. Okay, number 1c, we are given f of x is equivalent to 10 plus 3x minus x squared, and find f of 2. Okay, guys, functions, remember, just substitute in place of x, substitute what? 2. So f of 2 is equal to, in place of x, let's substitute 2. So it's 10 plus 3 into 2 like this, minus, in place of x, substitute 2, so it's 2 squared. But all right, so that's it, guys. So we can just put this in bracket if you want, like this one, it's fine. So it's going to be 10 3 times 2, that is 6, minus 2 squared, which is 4. So you can just use your calculator, guys, to simplify this. That's 16 minus 4, which is 12. As you can see, guys, it's just 1 mark. So even you can just use your calculator here, straight from this one, write your answer. Still, you can obtain full marks because it's just 1 mark there. All right. Then on this item 2, now we are given that find the values of x for which f of x is equal to 0. Okay, so the first part is to let which is our f of x. This is our f of x here, the one that we are given. This is your f of x. Now we are saying this function is equivalent to 0. That is 10 plus 3x minus x squared must be equal to 0. That is what it means on this part. So that means here we are going to have our f of x, which we said it's 10 plus 3x, okay, 10 plus 3x minus x squared. That is our f of x in this case. We equate this one to 0. So it's now an equation, when it's like this, it's now an equation, and you know that for an equation you have to solve for the unknown. So you're going to use your factorization quadratic formula depending with what you actually want to use. Okay, but the first thing is to rewrite, because we are supposed to have our order of the quadratic equation ax squared plus bx is equal to 0. This is the format that we need. So I'm just going to rearrange this, which is negative x squared followed by 3x followed by 10. I equate this to 0 so that I can solve. But cross-checking here, we can see that there's a negative that is affecting the coefficient of x squared. So what do? I divide by that negative throughout. So I use -1 to represent a negative. And the moment I divide this is to cancel, and it becomes a positive. Positive and negative, that's a negative 3x. Positive and negative, that's a negative 10. I equate this one. 0 divided by any number remains as a what? As a 0. So now from this part, we can solve this equation. That's where now you can use the quadratic formula if you want. X is equivalent to minus b plus or minus the square root of b squared minus 4ac. Take note, the division has to start from minus b, cover everything to the last part here, you divide by 2. So take note here on your formula, divide by 2a. All right, so that's it. You can use your formula, or I can just use factorization here, because I can see that the coefficient of x squared here is 1. So remember, I need 2 brackets if the coefficient of x squared is 1, just like what we did on the first part when we did factorization. Okay, so I'm going to put x here and x here. Focus with the constant, which is -10, so that it is going to give us -3. So which factors of -10 that we need? And these factors, if we add them, they must give us a -3. So we need factors of what? Of -10. So in this case, I have got -5 and 2. All right, if I multiply this, I get -10. If I add, I get -3. So that's what I'm going to have here, -5, +2. So that means either one of these brackets is going to be equal to 0. Okay, so that's it here. So either one of these must be equal to 0, so that I can solve for x. So transposing the minus x to this side is a positive, or x is equal to here. X is equivalent to transpose the negative, the positive 2 to that side is going to be a negative. Okay, so these were the possible values of what? Of x that were given. If they say f of x is equal to 0, you equate that to 0. Sometimes they can even ask you like f of x is equal to 5. What you simply do, take your f of x as it is, equate to 5. Then after that, formulate your quadratic equation, provided that it is giving you a quadratic equation. Then formulate your quadratic equation in this format. Then you solve either using the quadratic formula here, or you can use what? Factorization, depending if they are factors. If there are no factors, you are now left with quadratic formula, or some they can use completing the square. It depends with which method is best for you. All right, number 2a, we are given a quadrilateral, which shows this is AB, CD, this is a quadrilateral that you are given, and you are given to calculate AB. That is the first question. Calculate AB from this information. This is your AB here. So you're going to see that from this triangle that we are given here, it's a right angle triangle that we have got. We are given a right angled triangle in this case. All right, so from the right angle triangle, to find the third side, given 2 sides, we can apply our Pythagoras, guys. We know this, h squared is equal to a squared plus b squared. So that's it. Let's see. Our hypotenuse is the longer side, which is the one that is opposite 90 degrees, which is 12. So it's going to be 12 squared is equal to a and b. These are the shorter sides. So the shorter side is 8, which is bc, and this BA, which is our AB, the one that we want to calculate. So we have AB squared plus 8 squared, just like that. So 144 here is equivalent to AB squared, that's AB squared plus 8 squared, which is 64. So I can transpose the 64 here to the side, so it can be a positive, or it can be a negative, sorry, it's a positive here, so it's going to be a negative. So I've got 144 minus 64 is equal to AB squared. All right, so let's solve for AB. You can subtract these two. 144 from your calculator minus 64 is going to be 80. Okay, so this is 80 here is equal to AB squared. All right, so introduce your square root to remove the square here, the square root both sides. So we've got our AB now. AB is equal to square root of 80 in set form, or we can simplify this. Is going to give us something like 8,944. 271, something like that. Okay, so you can round off. Remember the degree of accuracy that you are given whenever it is not specific to 3 significant figures. If you are working with sides, 3SF. If you are working with angles, to 1 decimal place. So this is a side, AB is a side, so we're going to give to 3SF. That is, let's count 1, 2, 3. All right, so this 4 cannot change this 4, so it's going to remain as what? 8,94. So that's it. The measurements are in centimeters, so it means definitely this one also is going to be what? In centimeters. So that is our AB in this case. All right, so let's see the other part that we are given. We've got our AB now. The other question is to, okay, that was 2 marks. All this space for AB, guys, just imagine. The whole question was just to calculate AB. All right, so that was the whole question, and the whole page just covered to calculate AB. Okay, anyways, let's just see the other page here. All right, so now we are asked to calculate CD. So I want us to take the question, then we refer back to our diagram, guys, since we are not having here, so that we can clearly see. So know your question, calculate what? CD. Okay, so let's get back to our diagram. We want to calculate CD in this case. All right, so this is, let me remove this part here. All right, so we are going to have our CD here from C to D. This side is the one that you have to calculate. All right, so I want us to see something from this triangle that we are given now, because we can see that from triangle ADC, this triangle is a right angle triangle, yes, but this time there is an angle which is inside the triangle. So it means we can take advantage of our trig ratios, trigonometrical ratios from your soccer drawer, or some they use Churchill tower, whatever that you use. So we put soccer tower in this case. All right. So let us start by naming the size that we are given and the ones that we want. We want CD, and according to this angle, this CD is actually opposite, and the 12 is adjacent. It's on the angle and the right angle, so that's our adjacent here. So which ratio are going to use that has got opposite and adjacent? Definitely, we only have this ratio on tan. So that is going to be tan theta here, tan theta is equivalent opposite over adjacent, and we've got the angle now, which is tan of the angle, which is 46,5 degrees, is equal to the opposite, which is the CD that we want to calculate. So this is going to be CD over the adjacent, which is 12. All right, so that's it, guys. We can do your cross multiplication. We can just do our cross multiplication here to calculate our CD. So it's 1 times CD, which is CD is equal to 12 times tan, which is 12 tan 46,5 degrees. All right, so that would be tan 46,5. So CD at the end, if we multiply 12 times tan 46,5, you're going to obtain something like 12,64, something like that, 12,64. So guys, you just cross-check also with your calculators there, and make sure that your calculator is in degrees. Okay, so this is the decimal that you have, write everything, then you round off to 3SF because this is a side. So to 3SF, remember, we're going to have 3 digits, 1, 2, 3. So this 4 cannot round off this 6, so it is going to be 12,6. So that is it to 3SF centimeters. Okay, so we've got our CD here, which is 12,6 centimeters. Remember our AB we got it here, it was 8,94. So this was 8,94 centimeters. Okay, so that was what we got from this part. So we are just going to refer back to the other question and see what we have got here. All right. So now we are done with the CD here. We calculated this, we got 12,6 centimeters. Now 2A, item 3 is to calculate the area of the quadrilateral ABCD. Okay, so we need the area of the whole quadrilateral ABCD. Okay, so this is it. Let's get big. This is our quadrilateral here. So we need the area of this quadrilateral, that is A to B to C to D. This is our quadrilateral. Okay. Seeing cross-checking this quadrilateral, actually, we can see that we do not have anything that is like the shape that we are given. We are not even, we do not know which shape is this one. Okay. It's not a trapezium, it's not this. So what are we going to do? We are just going to combine what we know. We have got two triangles. So I'm going to work with this first triangle and the second triangle. Add the areas of these two. So these are right angle triangles. So which means we can obtain the area by combining these two. We know that our area is given by, this is area of a right angle triangle. So we are going to have area of a right angle triangle, which is half base times perpendicular height, that is area. This is area of triangle 1 plus area of what? Triangle 2. Okay, so triangle 2 is also a right angle triangle, so it's half base times what? Perpendicular height. Okay, so let's refer to the first triangle. What is our base and what is our height? So this is where we are going to have, or where we have 90. So this is your base and your height. Any can be the base or the height there. So you've got 8,9 for the one that you got on your first equation times what? Times 8. Okay. So this is what we have got. So we're going to have half of our base. We just indicate any of those two. So we're going to have 8,94 times the height, which is now our 8. Okay, so that's our first area, plus we move on to the second diagram. Let's see our area here. We said we have got this part. So this is where we've got our 90 degrees. So you can here say this is our base and this is our height, because it must be at what? At 90 degrees. As long as it's at 90 degrees, so we've got 12,6 and 12. Okay, so we've got 12,6 and 12 in this case. So it's going to be half of 12,6 times 12. So that is our area there. So you combine the areas of these two. Okay, so the first area will give us something like this part, guys. It's better to use your calculator. Okay, just multiply direct on your calculator. 35,76 square centimeters. This is area plus area of this triangle. That's 75,6 square centimeters. Then we can add, we obtain something like 111,36 square centimeters. So that is area. So this one was just issue of combining the area of the two triangles. Okay, you combine together, then that's your triangle. That's the area of the quadrilateral. All right, so that was it. Okay, let's see the other question, which is now 2b. So we are given 2b in this case, where we are given that 4 interior angles of a nonagon. Let me adjust further again like this. I think it's now clear. Okay, so we are given here 4 interior angles of a nonagon. Take note, we are dealing with a nonagon here. All right, so this is a nonagon, which means we are talking about a polygon with 9 sides. Okay, that's a nonagon with 9 sides in this case. Then we are given its sum, that these angles, if we add them, they are going to give us a 9. All right. They are going to give us 460. The sum is actually 4 interior. We are just given 4 of the angles is 460. The remaining interior angles are equal. Okay, so this is what we have. We have got a polygon which has got 9 sides in this case. Okay, and we are saying we are given 4 angles. So out of these 9, we have got 4 angles. Each of these angles we do not know, but we are given its sum. Okay, so the sum of these 4 angles is 460 degrees. Okay, we move on to the other part that we are given to say if these are 4 and out of 9, which means how many angles are remaining? That's 9 minus 4, which is we are remaining with 5 angles. So these 5 angles, we are now given that the size of each, okay, we are now given that the remaining interior angles are equal here. The size that we are given of each of these ones, they are equal. So if they are equal and there are 5 of them, let's just say each angle, let's just say each angle is equal to x. Each angle is equal to x, and there are 5 of them. Therefore, what is the sum of these? We are just going to multiply 5 times what? X, which is 5x. So which means the sum of these 5 angles that are remaining will be 5x. You just choose any letter of your choice. I don't know, you're going to use x, you're going to use y, but I just decided to use x in this case. Okay, so these 4 angles and these 5 angles that we have, if we add them, they are going to give us the sum, which means we are now having sum of 460 degrees plus 5x. Okay, so this is an expression that we got for the sum of angles, okay, of a nonagon with 9 sides. Now, From this part, we all know that we can actually find this sum, which is the numerical value, because this is an expression that we got for the sum. We got an expression, but we can calculate the numerical value in this case of what? Of this sum of a polygon with what? With 9 sides. And we know that the sum of any polygon is given by n minus 2 times 180 degrees. And which number of sides? It's 9, so it's going to be 9 minus 2 times 180, which is 7 times 180 degrees. And this is going to give us something like 1,260 degrees. Okay, so this is the sum that we have of this polygon, and this is the numerical value. This is an expression, but these two, they are equal because they all represent what? The sum. So we are going to take advantage of that to say if these two are equal, therefore 460 plus 5x is equal to 1,260 degrees, so that we can solve for x representing each angle, that the one that we are asked, because we are asked to find the size of each of the equal angles. So by calculating x, we are calculating the size of what? Of each angle. That is what it means. All right, so let's calculate our x. 5x is going to be equivalent to, transpose to this side, we are going to have 1,260 minus 460 in this case, which is 5x is equivalent to, we subtract the 2, we are going to obtain something like 1,800. It's going to be 800 direct, not 1,000, but 800, just 800. Okay, then you can divide by 5 both sides. Okay, so if we divide by 5, which means our x is going to give us 160 degrees. Okay, so this is 160, representing what? An angle. So it means each angle is going to be 160 degrees. So here we are just writing the answer. Here we're just writing our answer, which is what? Which is 160 degrees in this case. So actually, this part, guys, is you just need to know these formulas so that it doesn't even cost you much time of doing all these calculations and so forth and so forth. Okay, but actually, yeah, that's what we just have there. Okay, then number C, we are given a shop sells a refrigerator at $540 in the previous year. Okay, so okay, this is another statement. So a shop sells a refrigerator in this price. Okay, then in the previous year, the same type of refrigerator cost 8% less. That is the previous year. Calculate the cost price of the same type of refrigerator in the previous year. So we are saying this is what? This is currently, this shop is selling this fridge at what? At 540%, which is actually what we are having currently as the price. But they are now saying in the previous year, the same refrigerator that we had, it was 8% less. From which percentage? Okay, we know that every percentage starts at 100, so we are going to start at 100% to say at 100%, this is where we are now currently. So currently this refrigerator is costing $540, all right? So it is costing $540. But previously, in the previous year, it was 8% less. From this 100%, we are going to less 8%. Okay, so if we less 8%, we are going to remain with 92%. So which means this refrigerator now is at 92%. Previously, it was at 92% before. Okay, so that is at 92%. What was the price of the refrigerator? We do not know. So we are going to use our simple proportion here. As we can see, this one is less. Okay, this one is less, not more. So we are going to have 92 over 100, since this is lesser, times the price now, that is, we are given $540. Okay, so if you multiply, guys, that's like I said, this is paper 2. We are going to obtain $496.80. Okay, so it's going to be $8, but this is money with 2 digits after the comma. Okay, so this is what we are going to have. Or we could have said, since this is 8% less, someone could have just said this way. So we could have calculated this way. I know that this refrigerator was actually 8% less in the previous year. So let me know the 8% of this amount. Okay, so what is 8% of what? Of $540. Because we are saying it is 8% less the previous year. So we need to know the 8% of that 540. So 8% means 8 over 100 times $540. Okay, so if I multiply this, I'm going to get something like $43.20. It was 43.2, but remember it's man two digits, going to be 43.20. Then from this now we are saying what is the price now? So the actual price, which is in the previous year, is going to be for $540, one we are given, minus now the 8% because it's less. So whenever you are given a less, it means you subtract. So you're going to subtract now the 8%, which is $43.20. Okay, so if we subtract this, we are going to obtain the same amount of $496.80. All right, so that was another way that we could have just done this question. Still, we are going to obtain the same answer. All right, let's see the other part here. All right, I think that was the last part of the question. Okay, let's see the other one. Next page here, we are given matrices. All right, these are matrices, guys. Take note of matrices. It is given that matrix M is equal to 8, whatever that we have, and matrix N is 1, 3. Find Mn. This is matrix multiplication. Okay, so guys, you must know the matrix multiplication. So remember, guys, I told you the order first. You are supposed to know the order before you even multiply. Okay, it's a 2 by 2 matrix. You've got 2 rows and 2 columns. So this is a 2 by 2 matrix. Which is multiplying a 2 by 1 matrix. We are multiplying to a 2 by 1 matrix. As you can see, guys, these two are the same. It means multiplication is possible. Okay, these two are the same. So multiplication is possible, and the 2 by 1 is our answer. So our answer is going to be a 2 by 1 matrix. Okay, so this is just helping us to know what is going to happen later on. So let us do our matrix multiplication, guys. Row by column. So we're going to start with M here. Let us write our M, which is 8, -5, -4, 3, like this. All right, by the what? N, which is 1, 3. This is our matrix N. Okay, so we've got row by column. As you can see, there's just a single column here. So this 8 is going to multiply 1. So it's 8 times 1. Whatever that we get, we add. Since we are still having elements in this row, so we have to add -4 times 3. So we put -4 times 3 here. We are done with this row and column. We move down. We have got this row and the same column that we used before. So it's going to be -5 times 1, which is -5. Okay, let's just multiply here. Okay, let me just try to shift this side. All right, just a little bit here. So it's going to be -5 times 1. All right, whatever that we get, we multiply 3 and 3. So it's going to be plus 3 times 3. We add these two. Okay, so that is what you're going to have. As we can see, we are still in a row. That is where we have to add. Okay, so 8 times 1, that is actually 8. Plus and minus gives us a minus. So it's going to be -4 times 3, which is 12. Okay, then we've got -5 times 1, which is -5, plus 3 times 3, which is 9. So that's what you're going to obtain. Then we can combine everything. 8 minus 12, that is -4. -5 plus 9, this is 4. That's going to be a 4 here. Positive, actually, is going to be a positive. And also try to use your calculator. Paper 3 is an advantage type of equation because you are using calculators, unlike paper 1 where you are not having calculators. So you can just take that as an advantage. Okay, then the inverse of M. The item 2 now needs us to find the inverse of M. So for us to have the inverse, you know that the inverse, we have to find the determinant first of M. Okay, so we are just going to find our determinant. Let's get our matrix. Okay, so this is our matrix M here. Take note, which is 8, 5. Or you can just do it here. Let me just rewrite down so that we can find its inverse. So remember, our matrix M in this case was given by 8 minus 4. That was 8 minus 4 minus 5, 3. All right, this was our matrix M. Okay, so we know that for us to have the inverse, we must find the determinant first, or you can have this as determinant M, or you can write it like this. Okay, so the determinant, remember, is equivalent to the product of the major diagonal minus the minor diagonal, which is AD minus BC, provided that your order is in the form of A, B, C, D, like that. Okay, so our AD, in this case, we've got 8 and 3. So we're going to multiply 8 multiplied by 3. minus BC, which is -4, and -5. So it's -4 times -5 in this case. Okay, so let's combine 8 times 3. We have got 24 in this case. Okay, so that's a 24 here, minus -4 and -5, that's a positive 20. So if I subtract, I'm going to obtain positive 4. So that is the determinant. Therefore, the inverse of m is 1 over the determinant. Take note, 1 over the determinant, which is 1 over 4. Then remember what happens in your major diagonal. These two numbers are going to interchange positions. Okay, so you've got 3 and 8 changed their positions. So it's going to be 3 here and 8. Okay, then the minor diagonal, this one of B and C, you multiply each by a negative. This one multiply by a negative. So it's negative times negative, which is a positive 4. All right. Multiply this one by a negative also. So it's -1 times 5, which is a positive. So that's what you're going to have. So it's going to be a positive 5. So you multiply by a negative along the minor diagonal. Okay, that is what you simply do. You have your inverse of m. So that was the question, guys. As you can see, it was pretty clear. Okay, then m squared. Okay, so m squared simply means m times m. So remember your matrix m, guys, here. We are going to square now this matrix. Okay, so m squared, we are going to have our matrix m, 8, minus 5, minus 4, 3. So squared means you're multiplying it again. So that is 8, -4, -5, 3. Just like 3 squared is 3 times 3. Okay, 3 squared is 3 times 3. So it's the same like matrix also. You just have to multiply that matrix again. So let us simplify, guys, and see what you're going to have. So as you can see, we are back again to the row by column concept. This one is a 2 by 2, multiplying a 2 by 2. So our answer is going to be a 2 by 2 also. So row by column. So in this case, now we know the concept, guys. I'm not going to like show everything. I'm just going to multiply direct here. So it's 8 times 8, which is 64. Whatever that we get, we add to this one, -4 and -5, which is a positive 20. Okay, then we are done with this row and column. We still on this row, we move on to this column. So we do the same here. So it's 8 and -4, which is -32, plus -4 times 3, which is -12. So this is going to be a -12. Okay, we are done with this row in the column. Now we move on to this row. Start again with the first column here. Okay, so you're going to start again. So we've got -5 and 8, which multiplies -40, plus 3 times -5. If you multiply this, that's a -15. Okay, that's what you're going to have. Then we move on, still on the same row, this row, but now we move on to this column here. So it's -5 and -4, that's a positive 20, plus 3 times 3, which is a 9. All right, so that's what you're going to have. So you can combine everything. 64 plus 20, that's 84. So you put 84. -32 plus -12. So this is a plus and a minus. So we're going to have a negative. So it's -32, -12, which is -44. So you're going to have -44. Also, you've got the same thing, plus and minus, that's a negative. So you put -40, -15, which is -55. 20 plus 9 is just 29. This one is direct. All right, so that's what you're going to have in this case. So as you can see, guys, it's actually direct from this concept. It's actually direct here. It's m squared. All right, so that was the last part of the question. Let's see the next one. Okay, let's see the next question. The 3b now is for us to express this as a single fraction. Okay, so express the given fraction as a single fraction in its simplest form. So remember, simplest form, we have to find the LCM of these two numbers. We have got 4 and 12. Also, definitely our LCM is going to be 12. Okay, so let's divide 12 divided by 4, that is 3. Whatever that you get, you multiply to 2x minus 1, okay? Minus, take note of the sign, we are subtracting here. So here's 12 divided by 12, which is 1. Then you multiply everything to 3x minus 5. So take note about this negative here. That is where I want you to take note. Okay, so let's simplify the first part. 3 times 2, that is a 6x, 3 times -1, which is -3. We are done there. Then on the negative, it's -1 that is multiplying everything. So it's -1 times 3x, which is -3x. -1 and -5, that's a +5. All right, so everything here over 12. So that's what you're going to have. Collect your like terms here. Let us collect our like terms. We've got 3x and 6x here, so you can subtract these two. That is going to give us 3x. So we've got 3x here. Move on to -3 and +5. This is going to give us a positive. Okay, that's +2. Okay, that's a +2 in this case, +2 over 12. So here we do not have anything that is common. We can't subtract, we can't add, we can't divide anything. Just leave your answer like that. So that was it. Question C, we are given that there is a trapezium which has got an area of 63 square centimeters, and the sum of the length of the parallel sides is 22.5 centimeters. Calculate the perpendicular distance. All right. This is very, very, very interesting type of a question, guys. This is your trapezium here. Remember what your trapezium looks like. We have got two sides which are parallel. These are the parallel sides, and usually we call this A and B. And remember, your perpendicular height is this one. Okay, so now we are given that the area of this trapezium is 63 square centimeters, and the sum of the length of the two parallel sides is 22, which means this A and B, they gave you the sum of it. We are not given A separately or B separate. No, we are given the sum. And remember, from your area, you will know that our area of a trapezium is half sum of parallel sides times the perpendicular height. So they gave you this part here, A plus B, which is the sum, and also the area. So you're just going to substitute. Your area is what? It's 63. And the sum, what is the sum in this case? Already A plus B, they gave us the sum is 22.5. So it's half of 22.5 times what? The height. We do not know this height, and it's the one that we are asked to calculate here, the perpendicular distance, which is this height. Okay, so that is the perpendicular distance between what? The two parallel sides. So that is your perpendicular height. This one or this one is still the same. All right, so we need to calculate h, as we can see. So how are we going to calculate h? Guys, you can play any row. You can cross multiply. You can divide. You can multiply half and 22.5. I don't know what was best for you. So in this case, I'm just going to cross multiply here. Just remove these two here. Okay, let me indicate back on this part. Sorry for this. So I'm just going to cross multiply, take this value as over 1. Okay, so just cross multiply here. So it's 2 times 63, which is 126, is equal to, this means I'm going to be left with 22.5h. All right, 22.5 times h is 22.5h. So divide by 22.5. Divide by 22.5 in this case, so we can cancel. So that is our height. So 126 divided by 22.5, we are going to have something like 5.6 centimeters. So that was your perpendicular height in this case between what? The two parallel sides, the distance between two parallel sides, that is your perpendicular. So that was all for this question actually. All right, so that was all for this question. Just given this part, let's move on to the other part and see what we have. So this one, we are given a table which shows students' choices. We are given the information, type of instrument indicated as enjoyable, then the number of students. Okay, so for those who play Mbira, which is 18. So this means here there are 18 who play Mbira in this case. Okay. Piano is what? 14. Those who play piano is 14, right? Then we move on to the guitar. Here is 20. So this in this set here is 20. All right. And Mbira only is 10, which is this one that we are given. Piano only is 8, which is this one that we are given. Then we have got this part that is Mbira and P and guitar is 6. Okay, so we've got Mbira here and guitar here. These two in between. Here we've got a 6. I'm just going to write it here in between. Just know that we've got a 6 here. All right. Then what else? We've got piano and Mbira is 5. Piano and Mbira here. We've got 5 here. Then guitar and piano is 4. Guitar and piano here is 4. All right. then all the 3 is 3, this 3 that we are given. All right, so that was the first part that we are just given. Just to illustrate what does this part mean, that is what I wanted actually to have. Now let us see the questions. All right, so the question is on the next page. Okay, so let's see our next page here. We are asked to calculate the values of w, x, y, and z. Okay, so what are the values of x, w, x, y, and z? So let's get back to our diagram and calculate these values. Okay, so we need all these values, w, x, y, z. All right, so what are we going to do, guys? So from this information that we have indicated, we can calculate these values. So I'm just going to shift a little bit so that we can see this diagram. All right. So this is what we have here. So remember, we said that here there are 6 of them who are in this set between guitar and piano here. These people in between, they are 6, but we are given these 3 here. So to find W, we're just going to subtract. Since there are 6, therefore I'm just going to subtract. So W is equivalent to 6 minus 3, which is equal to 3. So it means here there are 3 elements, so that 3 plus 3, it gives us a 6. Okay. Between Bira and piano here, we are told that there are 5. So you do the same thing. So x is just going to be 5 minus 3, which is 2. So it means here we've got 2. So that 2 plus 3, that's a 5. The same with y here. Between guitar and piano here, there are 4 of them. So to find y, you're just going to subtract, which is 4 minus 3, which is a 1. Okay, so here we've got a 1 here. So that 3 plus 1, that's a 4. 3 plus 2, that's a 5. 3 plus 3, that's a 6. Okay, so that's what we had. What about z? If we are to cross-check on z here, we are going to use this whole set of the guitar, this one. The whole of this set here. This is the one that you're going to take. Okay, so just pardon this diagram, guys. Okay. So inside this set, we are given that all these elements, all of them, they are equal to 20. So it means if I add everything, I must obtain 20. And we have got everything in this. We have got y, we have got this one, we are just left with the z. So it means this set is going to be 20 minus all the other elements which are there. We are going to take our w here, which is 3. So we're going to subtract 3 plus we take the 3 also is included on the intersection, this one, because it's part of this set. Okay, plus the y here, which is a 1. So you add everything. Then we can subtract that from what? From 20. Okay, so if we add the 3 plus 3, which is 6, 6 plus 1, which is 7. So we're going to have 20 minus 7 in this case, which is 18. Okay, so it means those who play guitar only in this case, they are what? They are 7. That was the concept in this case. Okay, so we've got our value here. All right, so I hope it's clear. Let's just see the other part now. Okay, we are done with the values of x, y, and z. Okay, so let's move on to this one. Item 2, if 2 students were selected at random from the class, take note, how many students did we select? These are 2 students which were selected. Find the probability that both enjoyed playing the guitar. Okay, both enjoyed playing the guitar. Okay, what we need is that how many actually were playing the guitar. We are not told if they are playing guitar, and it's just those who are playing it. And we can see that those who are playing guitar, all of them, they are 20. We are not talking about someone who is playing guitar only, no, or someone who is playing guitar only, no. This 18 is representing those who are playing guitar only without playing guitar or without playing piano. But this 20 here, it's for those who are playing guitar, which means someone can play guitar and at the same time be playing piano. Someone can play guitar and also be playing. So we are going to take all the elements which are in guitar in this case, which is what? Which is 20. All right. So we have got 20 here over the total. How many people are there, or how many elements do we have? How many students were there? Okay, so that is what we have. So let's get back to our information here and let's see how many are we given. Are we given the total? There we are given on the first part, the survey that we have, it's a class of 40 music students. So the total is a 40 there. So we have our total. So our probability, remember, is the outcome over all the possible, which is 40. Multiply by, take note, we picked the 2 students from the same selection. So now it means this one is your first pick. So one student is out. So you've taken one student. These are the chances of picking one student. So to pick the second one, it means we are going to subtract because we've taken one student. So 20 minus 1, we are now left with 19. And also the total is going to be affected. So it will be over 39. So that is the, these are the chances now of picking the second student. So if you multiply this, we are going to obtain 19 over 78, and this does not reduce. Okay, so this one cannot reduce 19 over 78. That is what you're going to remain with. All right. So that was your second part in this case, the probability, guys. As you can see, it was a nice person though. Yeah, just have to revise as much as you can. Okay, so let's see the other part. Now we're asked to solve the equation. So this is just a normal equation. We are given 9 to the exponent of m minus 1, which is equivalent to 27. 9 to the power of m minus 1 is equal to 27. So from your indices, your exponents, we know that we can make sure that these bases are the same. So we are going to make 9 and 27. Since we want to find the unknown value, so 9 is same as 3 to the power of 2 into m minus 1, which is equal to 27 in base of 3. This is 3 to the power of 3. So we know that once these bases are the same, as long these bases are the same, it means the exponents are equal. So we're going to equate the exponents, which is a 2 into m minus 1 will be equal to 3. So what have you formulated? A normal equation, which is a linear equation where you can solve what for m, you can expand brackets, 2 times m, that is 2m, 2 times minus 1, that is negative 2, is equal to 3. Then we can transpose here, the negative 2 to the other side is going to be a plus 2. So let's add and see here. So we're going to have 2m is equal to 3 plus 2, which is 5. And we can actually divide by 2 both sides. All right, so divide by 2 here, by 2 here. So it means m is equal to 2 into 5, which is 2.5 or 2,5. So that is the value of m if we are to solve this properly. All right. So these are the typical questions, guys, that you'll be given. You are solving an equation, exponents. You just apply the issue of the bases, depending with how the question is what is given. But that was what we just did from this one. So done. Let's move on to the other page or another question. Number 5a, we are given to make x the subject of the formula. Okay, from this equation, let us make x to be the subject. So what are you going to do in this case? All right, cross multiply to get rid of the fraction. So you can cross multiply here. All right, so let's just put this one. All right, so okay, sorry. So we are going to cross multiply by x this side. Okay, just pardon me, guys, for this one. Okay, by x here, by x, by 1 here, so it's y times x, which is yx is equal to 1 times any part, guys, it remains as it is. So this one is going to remain as it is, which is p minus 2x. Yes, we want to make the subject x, but as we can see here, there is x and also here there is x. So what do I do on this type of a question? I have to collect like terms. That is the terms with what? Terms with x. So we're talking about terms with x. So let us collect those terms with x together. So we are going to have something like this. Transpose this is going to be a positive on the other side. That is yx plus 2x is equivalent to p. Already we had a p here, so we're going to just remain with this p on this side. Okay, now we have taken these terms and we've got x here and we've got x here. So what are we going to do in this case? We are going to factor out x or factorize. So we factor out because it is common in these two terms. So if I factor out x like this, I'm going to be left out with y here because it's yx divided by x, that's y, plus 2x divided by x, that's a 2, and equate this to p. So what am I going to do to remain with x? Divide by the bracket of y plus 2 both sides, divide by the bracket of y plus 2 both sides. So this can cancel here. I'll be left with x, which is equivalent to p over y plus 2. Okay, so this is p here. Take note, this is p over y plus 2. So that's how you simply solve for x, like under change of subject. Change of subject is actually solving for x, but you're solving for x using what? Using unknown values, not like you're actually finding the exact value of what? Of x. No, it's not like that. Okay. Then we are given the circle geometry on 5b, where we've got a circle, which is in the diagram. We are given ABCD, which is a circle that is center O. So take note, it's a circle center O. And I always told you guys to try to fill in if there is that condition where you can fill in. So this is a circle center O, and CD is a diameter. So from C to D is a diameter. And we know that a diameter subtends an angle of 90 degrees at the circumference. So that angle is going to be a 90 degrees, okay? Then we are given AOB, which is, let me just try to adjust this side a little bit. Okay, we are given also that AOB is 50 degrees and OA is parallel to CB. So O to A is parallel to this one. So we're going to use concept of parallels and so forth. Okay, so let's see the first question. Calculate or find OCA. Okay, so you need to find angle O to C to A, or CA, this angle here. All right, this is your OCA. I want us to see what is happening with chord AD. The chord AD is subtending an angle here at O at the circumference at the center here at O, which is 50 degrees. And we know that if it subtends an angle also at C at the circumference like that, the angle at the circumference is going to be half of this one at the center. Okay, so you're going to have 50 degrees divided by 2. Which is 25 degrees. So angle at the circumference is half of that one at the center. Or we are saying angle at the center is twice angle at the circumference. Okay, so twice means times 2. So this one, it opposes, so you divide by 2. So that's our CA in this case. So this was going to give us 25 degrees. All right, so let's see the other part that we are given. OCA, we're done on this part. Okay, so that was just 1% on this particular one. Then let's see on the other part now. We are given to find B item 2, angle OAD. Okay, so we need OAD. So we're going back to our diagram and see where our OAD is. Okay, so this is our diagram here. All right, so let's try to locate where our angle is. We're just going to work with this diagram as it is like this. Okay, so remember it's OAD, that is O here to A to D, this angle here. This is the angle that we need on this part. All right, so which concept are we going to use here? Remember from O to C, it's a radius. From O to A, it's a radius because O is the center. So it means OD is equal to OA. So that it actually makes this triangle to be an equilateral, an isosceles triangle. I mean, since we are given these two sides which are the same, and we know that opposite angles, they'll be the same. So the angle here at A is going to be the same as this angle at D. So it's going to be easier for us now to find this angle because we're just going to subtract 50 degrees from 180 degrees, then you divide by 2. Okay, so that's it. 180 minus 50 is going to be 130. That's 130 degrees divided by 2, which is 65 degrees. Okay, so it means this angle here is 65. This angle here is 65. So we have got our angle here, which is 65 degrees. So this actually gave us 65 degrees, which is OAD. Then we move on to the other one. Find angle ABC, item 3, that is angle ABC. Okay, so let's go and locate our ABC. A, B to C. So this is ABC, this angle here. This is your ABC. Okay, I want us to see something. From A here to B to C to D, we are actually having a cyclic quadrilateral because all these vertices are on the circumference. This angle at B, at A, at D, at C, they are on the circumference of a circle. And you know that opposite angles of a cyclic quadrilateral, they add up to 180 degrees. So these are the opposite angles. So it means the angle at B is just going to be 180 minus 65 degrees. Okay, so 180 minus 65, that's 115 degrees. Okay, so this angle is 115 degrees. And also, guys, when you're answering, fill in your values inside there. Try to fill in your values so that you're not going to mistaken. Okay, so we got 115 degrees on this one. All right, so this is 115. Let's see the other part. ABC, then item 4 is CAB. Okay, that's CAB. Okay, so let's cross check which is our CAB here. CAB, we've got C to A to B. Okay, so this is our CAB here. This is your CAB, this angle that we're having. Okay, so which concept actually are we going to use in this case? Okay, remember we are given the parallel lines before. We were told about the issue of parallel lines in this case. So how are we going to find our CAB now from the issue of parallel lines? Okay, let us see what we have got here. I want us to see something before we move on. From O to C, okay, it's a radius. This one, O to C. And from O to A, it's a radius also. So these two are the same, just like what we did on triangle OAD. It is the same concept also with triangle OCA. So which means the angle here at A, this remaining angle at A, this one that is in between, is 25 degrees, because we know that opposite angles, they are going to give us the same angles, since they are equal from what? From the opposite side that we have. So this is 25, this is also 25. Then I want you to see what is happening with the concept of alternate angles. We are creating a Z like this one. We've got a Z there from our Z angles, okay, from this one, B to C to A to O. There is a Z that is created. So this angle at C is 25 degrees. All right, so we can know this is 25 degrees at C from alternate angles. So we are just left with this angle at A. So what are we going to do? We know that angles in a triangle, they add up to 180 degrees. So if we know this concept, therefore, we are just going to subtract these two so that we can have our CAB. So our angle CAB is going to be 180 degrees minus these two angles that are inside the triangle, which is 25 degrees plus 115 degrees. Okay, so that will be 180 minus, let's just combine, guys. We're going to have 106, 140. We're going to have something like 140 here. Okay, then we subtract 140 minus 180 minus 140, which is 40 degrees. Okay, so this angle here is going to be 40 degrees. Okay, so this is the concept of parallel lines. It helped us to know that this angle and this angle are the same. But you see that triangle OAC played also a role, because we used that concept of what the radii concept, that is radius are the same. So using this radii concept, we can see that we are going to end up with what? With an isosceles triangle. All right, these two angles, they are the same. It provided that O to A, provided that O is the center, and we have got these two sides that we are going to have here. So this is the radii concept. You know that the base angles are the same. So that is what we had in this part. And actually, that was everything, guys, to obtain these marks here, which is actually 7 marks, guys, for this one, as you can see. All right, so okay, I have to change this. I forget to change this setup. So now you see what it does, because I forget to change. All right, screen sharing stopped. Sorry for this. Guys, you see now I end up using this part a little too late. All right. Guys, it's just this, you know, these technical errors, guys, how they do these things. Okay, but anyways, that's what we actually had in this case. We are going to see that it's actually a total of what? 7 marks for this particular type of a question. So it's just a matter of knowing your theorems. As you saw, guys, working with theorems, it's actually very, very, very important, okay? And let's see this part here, the next question. All right, it's actually on construction. Yeah, construction, guys, remember. So on construction, we are given answer the whole of this question on page 15. We are given the next page where we are going to do our construction, and use ruler and compasses only for all constructions, and show clearly. You are supposed to do everything in a clear way, the construction lines and arcs. Okay, all constructions should be done on a single diagram. Okay, that's what we had. So in this case, it's actually, it was we are given a certain line that is on the next page. This one, let me show you what it was like. Okay, so this is what we had. We're given line AB. So now I don't know how is it like, because this part we are just going to use our AB like this, whether we adjust or so forth is going to remain as it was. So, but I'm just going to show you what you actually do on your construction. So this was our line B that we are given. So we need a parallelogram AB CD. So guys, and the angle AB is 120 degrees. Remember, I told you guys the first thing that you do is to have a sketch. So there is an angle. Make sure that the angle is on the base. So ABC. So from our diagram, let's just have our sketch here. So it's a parallelogram. So I've already given here A to B. So which means our sketch is going to be like this. Just a sketch. Okay, so we're going to have our A, B, C, D. Remember, it's a parallelogram, guys, where these two sides, they will be parallel and equal. Okay, these two sides are also parallel and equal. Okay, so we've got our AB, and we're given the angle here, which is ABC, is 120 degrees. So it means here we are going to have 120 degrees, all right? Then what else? AB is 8 centimeters. So we've got AB that is 8 centimeters. Here, this line, this AB is already given, is 8 centimeters. So it means this is also 8 centimeters since opposite sides are parallel and equal. And we are also given BC is 10 centimeters. Okay, so from B to C is 10 centimeters. BC is 10 centimeters. It also means this is also 10 centimeters. So this is our sketch, and we must know that if this is 120, remember this are parallel lines. So this one will be 60 degrees. Since these are co-interior angles, they add up to 180. So this automatically becomes 60 degrees. Okay, so on our construction part, definitely we said we need our ruler and our compass. These are the two things that we actually need here. All right, so let's see if we are going to win here. If we need our ruler. Okay, so we put our ruler and our compass. Okay, so these are two things that we are going to need. All right, but here I'm just going to just adjust this slide since I want to do proper construction. I'm just going to make a small adjustments, small, very, very small, just to extend this line. We know where we are going to start from, just to extend a little bit. Okay, so here I just extended, but we are working with this B. Remember where your B is. Okay, so we need an angle of 120 degrees at B. So for us to have this 120, remember your construction that we do not have an angle of 120 direct. So what are you going to do? We construct an angle of 60 degrees on this side here. 60 degrees, the remaining angle becomes 120. Okay, so that's what you simply do. So remember how you construct your 60, you're just going to make just any adjustment of your choice here. Okay, so at B, let us make sure that the needle point is at point B here at B. Okay, this needle point here is at what? At B. So at B, you construct an arc. Remember, you want your 60 degrees to be on the right side. So you're going to construct an arc on the right side. Okay, so let's construct our arc here. Is it fine? Okay. Okay. Sorry for this, guys. Let me just try to reverse a little bit. Okay, like this one. So let's say for arc like this. Arc like that one. So almost like a semicircle. Okay, it's not like you're going to have a complete semicircle or something like that. Okay, just like almost like a semicircle like that one. Okay, now you step at this point, which means what we at this point here where this arc and the line meets. Okay, so at this point you shift your compass. In this case, just shift it like this one so that you can be able to mark an arc, but make sure that this needle point here is at what end. You do not change the distance also that you are given. Okay, you do not change this distance in between the needle point and your pencil. Do not change that distance. You step at what? You step at this point. So just make sure that you step properly, guys. All right. So by stepping this, okay, let's try to shift it a little bit so that we can start now to have our arc. So in this case, okay, let's shift a little bit. Yeah. All right, so I'm going to shift like this one a little bit. Yeah, somewhere at this stage, that way maybe you can start to have what? To have your arc. Okay, so draw an arc to meet the first arc like that one. Okay, so once these two meet at this point, you can remove this part so that you can join where these two arcs meet back to what? To B. Okay, so it's now you and your ruler now to mix up this part here. All right, so let's let's see what you're going to have in this case. All right, so the joining part, guys, actually, I don't know we are going to win or not, but actually, we just need to join those points and so forth. So it's just because of these instruments, you know, them guys, that you're supposed to actually learn a little bit of them, so that you can be efficient. Okay, I have to adjust again. So I just need to adjust so that these 2 points, they are now accurately linking. Okay, are they linking? Not yet. All right, so let's rotate again a little bit. Are they linking? Not yet. A little bit again. So guys, very sorry for time. So this editing thing, guys, now I'm not going to do the editing. I'm just going to give you this video like this, guys, okay? So that you know how it takes to record these videos, guys. All right, so I'm just going to join this part, all right? Join this, okay, let it be, let it go to that side. Let's try to take our diagram a little bit down, so that we can at least have it again, join again here. So at this point, we can actually continue with this line a little bit here. All right, something like of that nature. So this is where we are now having our 60 degrees. So you're saying if this angle is 60 degrees, definitely the one that is remaining inside is 120. So you indicate the one that is inside, not this 60. When you need this one, so you indicate this one, which is 160, 120 degrees, which is this angle. So you can just write 120, and we are good with this one. And remember, we said here on our sketch, our AB is what? Our AB is 8 centimeters. So we've got our 8 centimeters here. And we need 60 degrees. We also said at B here, we are going to have what? At B, we are going to have 60 degrees. So at B, we are going to construct again 60 degrees so that it can be easier for us. So let's just go at A, sorry, at A, not at B. So we need the 60 degrees also again on the right side. So we're just going to repeat what we did, construct an arc, which you just make like just like a semicircle, okay, but you do not like have a complete semicircle. All right, you just mark an arc. I'm not directly at A, but okay, I hope you understand what is happening. Then with this arc, I just shift it back so that we take this needle point. Okay, so with this needle point, we come back at this point here. All right, so let's shift again at this stage. Yeah, you can even start at this stage, or I can even start at this stage, join without changing the length. What is important, do not change this length. All right, do not change this length. And take note, you'll be given that approximation. When your answer is not directly inside the range, they will give you a certain approximation of what? Of when they are marking. So, but try to do something that is accurate, guys, okay? Just try to have something accurately done. Okay, so you join just like previously. What we did previously. All right, so we can remove our instruments. All right, we can just take them aside. We are going to use them again. So this is what it's going to look like. Let me adjust this way. Okay, so this is what we are going to have, something like this. Remember, this is where our A was. Okay, I forgot to indicate the pen. This is where our A was. Okay, now we've got our 60 degrees. Yes, we can indicate this is 60, but it's not important because it's not like given on our diagram. So let us measure here. We know that from B to C along this 120 degrees on our sketch here, along this 120 from B to C, we have got what? 10 centimeters. Okay, so we're going to measure 10 centimeters from this part. Okay, so let us take this diagram this side. Let us measure our 10 centimeters. So this is your ruler that you're going to have on your ruler there. Measure 10 centimeters. Okay. So already here I'm having the dimensions 0 to 10 on your ruler. So you take your compass. Yes, this one of mine, on this one, it can actually give me the length. Like I can actually see, as you are seeing, if you adjust, it's giving us 5,8. whatever it's giving us. But for you, you're supposed to get direct at 10. So this is our 10 centimeters here. As you can see, it's 10 centimeters. All right, so we have got measured our 10 centimeters. As you can see, it's actually indicating 10 centimeters. Okay, so with that 10 centimeters, you place it at what? At B. This is what you're going to place because you need B to C. Okay, then try to rotate your compass to this stage so that you can mark an arc. Make sure you are stepping direct at what? At B. Okay, you just mark an arc on this line. This is 10 centimeters. You do the same at D again because you know that from A to D is 10. So you do the same at what? At A without changing the length. Okay, without changing this length. Let's just shift a little bit. Okay, so we can now have our arc. Mark an arc like this. Okay, so that's what you're going to have. So these arcs that we have marked here, they are 10 centimeters. 10 centimeters from A, 10 centimeters from B. That's what we have here, 10 centimeters and also 10 centimeters now. All right, so with this part, what are you going to do? We join because we know that from B to C, definitely this is our C. All right, definitely if this is 10 centimeters, so definitely this is our C, this is our D, because we've got 10 centimeters. So what are you going to do? Just join these 2 points, then we can complete our shape. Okay, so let's complete this shape now by joining these 2 points like this one. Okay, so by joining, we have completed our parallelogram. That means we are now having A, B, C, D as our parallelogram in this case. And we can even name this side because remember on our sketch, you said this is also 8 centimeters. So we are going to have also 8 centimeters here. All right, so this will be 8 centimeters. Okay, and this is construction. You are not drawing. This is a construction. Construction, you do not do as if you are drawing a diagram like this to say it's a parallelogram like this. You join the points they are directly. This is your no guys, this is construction. Try to show us that you are constructing. This is not something that you are having accurate. It's from construction. So these arcs, do not remove them, leave them like that. Okay, so it's not supposed to be directly linked to A or linked to B. No, it's not supposed to be like that. All right. Okay, so it auto saves after some time. That is why it takes time, guys. So sorry for that. It just after some time it auto saves. Okay, so now this is where we are now. We are having a complete diagram. So let's refer back to the questions. All right, so from the questions we are done constructing. So the first question now is item 2. Construct the locus now still on the single diagram. Okay, the locus of points equidistant from B and C. So B and C, these are 2 points and they are on a line. So remember guys, I told you that this is what? Line bisector. You divide that line into 2 equal parts from B to C. Okay, so let's get our B to C here. Okay, so where do we have our B and C? This is where we are having our B. We put our B at this point and our C at this point. So we're supposed to bisect this line. Okay, so that is what it means. So let us take our instrument again so that we can bisect this angle, okay, this line. All right, so let's just, we know that to bisect a line, you open more than half of the line. Okay, so this is at B. You just rotate this. You can cross-check that it's more than half of the line from what you're given in this case. Okay, just open more than half of the line. Then after opening more than half of the line, you step at what? At B. The first point is B. Okay. Then you mark an arc. You're going to first mark an arc just inside the diagram somewhere here. Yeah, we can start marking here. We mark an arc like this. Without changing this part, we move on again to the same B, but on the other side. Now let me just try to shift it. Now it doesn't show. Okay, so let me just shift it this way. So without changing the distance, okay, you do not change this distance. You mark again at B, mark another arc on the other side. All right, so without changing this distance. Okay, so I'm just going to rotate it, shift it a little bit. All right, so it's somewhere here, guys. Oh, I'm still having my needle point this side. That is why I'm now seeing what is happening. Okay, so this is supposed to be like this, guys. All right, so let's shift like this one. Okay, so we're going to have to mark another arc on this side. without changing that distance that you had. All right, so you mark your arc, so it's somewhere here. Okay, that's an arc. Let's just hope they are going to meet. If they don't, we come back again. Okay, so that is at B, you mark an arc there and an arc on the other side. Then at this point, C, you do the same. Make sure that you are somewhere here. So you mark an arc. As you can see, they will meet at this point. Okay, so you mark an arc at this side. Okay, we are done with this point. So you've marked an arc. You do the same on the other side here, you mark an arc from this side. Okay, but here you're going to see if you mark, they're not joining. Are you seeing that they're not joining? Okay, leave it like that, just leave it like that. Mark that arc, then you leave it like that. Okay, they are not joining. It's because we made a short arc here. So we're going to back where we made our short arc at this point. Then we make it a bigger arc. Okay, so that's it. Just like that, that's it. Okay, so I'm just going to take this a little bit. So now it must follow the same way that it followed before. Okay, so now let's conclude our arc here. It just was a little bit, okay, a little bit, okay, somewhere here. All right, so you mark back so that they can join like this one. So you don't change anything. You just go back to the same B that you had before, mark an arc from there. Okay, after that, you can see they are now joining. So it means by joining these two arcs now, we have what? We have bisected this line BC. So that is what we are going to have in this case. So you join the middle points, these ones where they are, where these arcs meet. All right, it's going to be like this. Let's just this way. Okay, so where these two meet, you join them. All right, so that's what you're going to have in this case. All right, so you join these two like this one. So we have bisected the line, and we can just even increase even on this side so that we can even drop, because we do not know what is going to actually happen for on the next question. So just be rest assured that anything can happen. So make sure that everything is clearly presented there. Okay, so that's what you're going to have. So you've bisected line BC, but the question, take note, was for you to have the locus of points equidistant from base, but you, on construction, you are bisecting. So this one is a line bisector. So this one is a line bisector of construction, guys. I told you about this. Okay, then we move on. The bisector of ABC. This one is direct. This one is construction. We are already told bisect angle ABC. That is what they mean. So which is our angle ABC? That is our A, B to C. So we are going to bisect this angle of 120 degrees. Okay, so to bisect, all we need is our compass here. So let's take our compass. You take the needle point at B. Okay, at B here. You mark two arcs along the lines, along the points that are giving what? Now let me just try to change the marker here. So you use the lines which are creating this 120 degrees, all right? So these are the lines that you're going to take, which are creating 120 degrees. And like I said, let me use this one. I don't know if it is going to be clear. Okay, so the line that is creating 120 is line AB and line BC. So you mark an arc on line AB like this, okay? You shift your compass on this side, you mark another arc on this line, the lines which are creating the angle, like that's how you bisect it. Okay, so let us combine like this one. So after marking these arcs, okay, so we've got these arcs. Let me remove so that you can clearly see. We've got this arc here at on line BC and this arc on line BA. Okay, then you move or you take your compass back to those arcs. I'm going to start with this one at on line BC, this one. We mark now an arc into this diagram inside. So you just mark an arc inside the diagram here. Okay, so we just mark as an arc. Make sure that it's completely shown. So you're just going to mark an arc like this one. From this point, you do the same at this point at what? At this point between on line what? On line AB. Okay, so I'm just going to shift this side. We do the same. We mark an arc back to this line like this one. So as you can see, these two arcs, they meet at a certain point, which is this point. So where these two arcs meet, you join back to B, to the point B now. So this is where we are going to join our points now from that arc, okay, to point B. So somewhere here. Let's just try to adjust, or let me reduce my ruler here, sorry. Okay, so it's fine, or I can even take it this way. I wanted to reduce this ruler, okay, like this. Okay, so at least I can use a smaller one, but it's now too small. All right, so let's see, guys. Let's see. You see, guys, how hard it is to record these videos. It's very, very hard. But I hope you understand what is actually happening here. It's not about being hard or so forth, but it's about understanding concept. All right, so this is where we are going to have it. Adjust also this side. All right, I think it's a little bit, all right, somewhere there, somewhere there. All right, so I'm going to join this. Let me change to the normal one or the black one. I can use the black one. All right, so let's join these two. So these ones, they'll actually meet at a certain point. They will actually meet, then you join them. Oh, guys, we skipped a little bit because they was supposed to be at this point, but okay, just don't worry about it. That it was supposed to be directly at that point. So this is what you are going to have at the end under bisecting the angle. So that was it, guys. You've bisected your angle, joined and everything. Then let's see the other question now is mark and label the point X. Okay, where does this point X, where is it located? The point X, it lies on the bisector of ABC and is equidistant from B and C. So it lies on the bisector, which means it lies on this bisector that we did. Remember, we bisected an angle like this, then we bisected. So where those two bisectors meet, that is where the point X is situated. Okay, so let's locate here. So you can see that the bisector is here, the angle bisector is here, so they are going to be at this point here. So I think it's just a little bit outside. That is where your X is going to be located. Okay, so I don't know from your diagram, guys, how it is going to be, but it's a little bit outside of that diagram, like as you can see here, a little bit outside. So that is where our X was going to be actually be located. So that's what it was going to look like. And let's see the other question. The C part is now to describe the locus. All right, so take note here. Describe the locus that the bisector of angle ABC represents. Okay, so remember we bisected angle ABC. So what does that locus represent? Which locus states about bisecting an angle? So we are now going back to our locus. Remember, for you to use the locus, this one that bisects angle is said that it is the locus of points. So this one, it is the locus of points equidistant from what? From the two lines. So it is the locus of points equidistant. This is equidistant from AB. The sides that are creating the angle is AB here. So we are given AB and the other line, which is BC. So you take from that angle AB, BC. Okay, so it's AB and BC like this. So as you can see, where the B is repeating, it means you bisected. So if the question could have asked to say, construct the locus of points which are equidistant from AB and BC. You bisect the angle. But now they gave you as a question under construction for you to bisect. Now they are asking you as a question under locus to describe that locus. What does it actually represent? So that was actually what we just needed from this part. All right, so that was the question 6, guys, on your construction. So take note, guys, on your diagrams and make sure that everything is clear. Make sure you have a sketch. From a sketch, you can actually draw whatever that you are given. All right. Then on number 7, we are now given a quadratic. This is a quadratic graph. Remember, this is y is equal to half of x into 5 minus x. If you are to expand this, the x, when it multiplies the x is going to give us an x squared. So this one is a quadratic graph. Okay, so the first question is calculate the value of p. So p here corresponds when x is equal to 3. So you just substitute in place of x is 3, in place of x is 3. So we are going to have half of 3 times, this times here 3, 5 minus 3 is 2, so you're going to have what? 3 at the end, so it's 3. That is what you're going to have. So our P in this case was going to give us 3. Then answer this part of the question on the grid on page 17. All right, so what are you answering? We are going to draw the first part on number B is to draw the graph. Okay, so to draw the graph, we need the points that we are given. So you need to mark the points according to the scale. So let us first analyze the graph and see how it looks like. Okay, so this was our graph. So you just need to analyze your graph according to your X. What is the scale that is being used? So it's 2 centimeters to represent 1 unit. On the Y, again, is 2 centimeters to represent 1 unit. So this scale was fine. Take note, this is your X-axis here, and this is your Y-axis. All right, so this scale was fine. Now let's mark, because we know for us to sketch this, we need the points. All right, so let us take our points here. We need these points okay, cancel this. Okay, so the first part is -1, -3. So this is what we need on our table, -1, -3. So when X is -1, Y should be -3. So we are going to mark where this is going to pass through. Okay, so X here is -1, Y is -3. So these two, they meet at this point. Where these two meet, you mark a point. So that's -1, -3. All right. Let's move on to the second point. 0, 0 here. When X is 0, Y is equal to 0. So that is 0, 0. That is at the origin. When X is equal to 0, Y is equal to 0, you just mark a plus there, point. Okay. The next point is 1, 2. When X is 1, Y is 2. So that's 1, 2. All right. So that's 1, 2. 1, 2, somewhere here. All right. So X is 1, which means we are here. When X is 1, then Y is 2. Somewhere at this point, you mark your point again. So make sure that you mark is very, very small. Don't make it like bold code like that one. Okay. Just mark a small point. Okay. So that's 1, 2. Then we move on to 2, 3. 2, 3. When X is 2, Y is 3. So that is 2, 3 here. When X is 2, Y is 3 at that point. So this is your 2 here, and your X is 3 at this point. So you've got 2, 3 somewhere here. Just mark a plus where these two meet here. That's our 2, 3. Then let's move on to this point. 3, 3. Remember, our P is 3, so it's going to be 3, 3. When X is 3, Y is 3. So you've got 3 here and 3. So this is where we are going to have our point. Okay. Then we move on to the other one. It's 4, 2. When X is 4, Y is 2. So we've got 4 versus 2. All right. So let's see where our point is. Okay, that's 4 here and 2. So that's 4, 2 at this point. All right. Sorry, it's now went to the other part because of it was slow a little bit. Okay, so let's get back to our page. Let's wait for it to save a little bit. Okay, so this is 4, 2 here. Okay, let's get back to this one. 5, 0. So we've got 5, 0 here. All right, so that's 5 versus 0, which is when X is 5, Y is 0 there. And another one is 6 minus 3. That's our last point. 6, -3. So you just make sure that you mark these points properly, guys. Okay, so 6 minus 3 is somewhere here. When X is 6, Y is -3. So it's at the end here, 6 minus 3. So that's what that's where we are going to have our point 6 minus 3. So I want you to see what is happening at the end. These are the points that you had, and if you want to cross check them, all you need is to join them smoothly. You produce what? A curve. So guys, you just have to draw a proper one. Is because here, guys, you know that I'm using something here, but you're supposed to draw a smooth, nice curve that you're going to have in this case. So you just join your points properly. Just join your points properly. Okay, so you're just going to see if we are going to win here. All right, so here we are not going to join here to make it a straight line like this one. No. You just make a curve. At least it must be at least let it be in between 2 or 1 box somewhere there. Let it not be that much. Okay, then we move on to this part. Now I was used to paper where I can rotate my points. Was this point 4, 2? Why is it like it's now going somewhere? Let's cross check. Was this 4, 2? Okay, that was 4, 2. So I don't know how it is going to look like, guys. You just have to pardon my diagram. But you're supposed to draw a smooth curve, all right? A smooth curve. Smooth curve. All right, something of this nature. Yes, mine is actually is not smooth, as you can see. Mine is not smooth, it's crossy. This one is the crossy one. Okay, but remember, they actually need you to have a smooth curve. So you just have your smooth curve, then you name the equation of the function, the graph that you're given, which is half x into 5 minus x. All right, so that's what you're going to have in this case. And from the graph that we had, now the question is asking us to, remember, we are asked to use the graph here, draw the graph, then use the graph now. All right, this is what you're going to have here. You're asked now to use the graph to estimate the maximum value of y. Okay. So when you are using your graph, you're going to just take that one, the maximum way, which is where the graph is what is having a turning point there. So that's where our maximum value is. Okay, so in this case, we are saying where your graph is having a curve at the end here, that's where you're having our maximum value. That is where there's a curve here. So it depends with the graph that you're having, but all you need is to just draw a straight line from that point. Okay, just draw a straight line from this point straight to your y-axis. Okay, so you draw straight to your y-axis, direct at that point. Okay, so I'm just going to draw straight to the y-axis. Then you take the value that is corresponding on your graph. Remember, you're told to use your graph. So this is what you're going to get from your graph. So this is 3. Remember, this is 3,1. 3,2 somewhere there, or 3,15. According to mine, is actually 3,15. So it depends with your graph. I don't know what you're having on your graph in this case, but as for mine, it was somewhere at y is equal to, you say 3,5. 3,15, yeah, something like that. That is the value of y, 3,15. So you just take, according to your graph, maybe it's a 3,2. Okay, that is what you simply have. Okay, then the range of values of x for which y is positive. We want where y is positive. Okay, where y is positive, like this is your x-axis. So down here, y is negative. Above the x-axis, y is positive. So we need where y is positive, that is above the x-axis. Okay, where is it going to start and end at? Okay, so when this is positive, I want us to see what is happening. This is our x-axis here. On our graph, this is your x-axis. So above the x-axis, it is positive. Above the x-axis, okay, I didn't indicate the pen. Okay, let me indicate my pen back. Okay, it's saving now, it's saving. Okay, so this is my x-axis that I'm having. So we are saying above the x-axis is positive and down it's a negative. So from this point at 0 here, it goes to the positive because it's above the x-axis, and it goes back until this point at what? At 5. So it's between 0 and 5. Our function will be positive. So x is going to range from 0 to 5. So it means our x in this case is going to be greater than or equal to 0, less than or equal to 5. Because at 5, y will be equal to 0, and when it is equal to 0, it means it's a positive. So you take from 0 to 5. Then D item 1, draw the suitable straight line that should be used to solve this equation. Okay, let me adjust so that you can see the equation. We want to solve this equation, but the first part is for us to draw the line that is going to solve this equation here. Okay, so remember, this is already given here. This is representing y on this part where we are given to draw the graph of y is equal to, on this part, we are drawing the graph of y is equal to. So this indicates y, so we're just going to draw the line of what? Of y is equal to x minus 1. Okay, so how do I draw the graph of y is equal to x minus 1? This is what I need for me to draw this graph. It's actually a straight line. Okay, so this is a straight line. So we want to draw the graph of y is equal to x minus 1. So remember, all we need is to have what? Is to have our equation, and you can use any method. You can use table values, or you can actually use double intercept in this case. Okay, so you can ask yourself, when x is equal to 0 from double intercept, or you can use table values. Okay, this is xy here. So I'm asking myself here, when x is equal to 0, what is the value of y? Y is negative 1. Okay, then on this part, I'm asking myself, when y is equal to 0 this time, so I'm saying at this condition, this time, when y is equal to 0, what is the value of x? So transpose the -1 to that side, it means 1 is equal to x, so x will be equal to 1. So I just need these 2 points. They are enough for me to have this line that is at 0, -1. Okay, so we need the point 0, -1 here. That's 0, -1 at this point. Okay, so you mark up your point 0, -1. That's this point. And the other point was 1, 0 here. This is 1, 0. So we're going to take this point at 1, 0, which means x is 1 and y is 0. That is 1, 0 at this point. Okay, that's your 1, 0 here. You mark that point. Then with this point, the double intercept is enough for you to draw the line, or you can use table of values. I don't know what was best for you, but with this, you can actually draw your line, or all you need is our ruler here. So let's just take our ruler and join the 2 points. So we're now back to that issue, guys, of rotating and doing this and that. Okay, so let's just hope it's not going to take much of our time just to rotate this ruler and to join our line. I don't know their ruler, guys, how they actually assembled, but in other softwares, the ruler is actually easier to use. This one, it seems like there's a lot of things that you actually need. Okay, so I'm just going to join here. Okay, so let's join and see, but it's not accurate, guys. You see, it's supposed to be direct at that point. Okay, so it's just because of this ruler thing that is actually affecting us. But your points are supposed to be direct at that point, like this part at this point here and at that point. So this is the line that we are going to have at the end. Then you just name the equation. You just name this line. Remember, we are given its equation. It's y is equal to what? Y is equal to x minus 1. Just name the equation. Okay, so that was for you to just draw the line. That was the question for you to draw the line. Then let's get back to our question. Now, after the question, we are now given to use that graph now that we had drawn and the line to solve the equation. Now you're solving the equation. So what does this mean? Where these two graphs meet, they are equal. Where we are given a quadratic and a straight line, that is where your answers are going to be taken. Okay, so all you need is to go to the graph, because we are saying these two graphs, they are what? They are equal. Okay, so let's get back to our graph here. So at this point where these two meet, direct, and at this point where these two graphs meet, that is where you're going to mark direct to the x-axis using your ruler. In this case, we just place your ruler at this point, okay, where they've met, and you join direct to the x. You do the same at this point. You join direct to the x with your what? With your ruler in this case. All right. So that's what you're going to have in that case. So it's gonna depend with what you have on your graph there. But yes, somewhere 1, 2, 3, 4, 5, 6. Yeah, somewhere like 6, 7, 6, 7, 8, 9. So it's somewhere like 5, 3,5, somewhere there. So these are the values of x now that you're taking. The x1 is 0, according to your scale, you count your box according to your scale 1, 2, 3, 4, 5, 6, something like negative 0,6. Okay, or the other x there is 3,5, 3,6, somewhere there. So you take those points where your graph is meeting with the x-axis. Now where this part have met at these 2 points, then you join to the x-axis, you join to the x-axis just like that using your ruler. All right, so that was the concept on this question. Let's see the other part that we had on the previous question. You're now given on E to find the area bounded by the graph. So this first thing is bounded by the graph, the x-axis, and the line x is equal to 2, x is equal to 4. Let's start by just having area bounded by the graph. Okay, bounded by the graph and the x-axis. That means we need this region between the graph that we have and the x-axis. This is the region that we need. Okay, then we move on. We need the lines, which is in this case the line of what? X is equal to 2 and x is equal to 4. So these are the two lines that we need. So we're going to draw these two lines. Let's just put in our instruments here so that we can just draw this line. X is equal to 2 and x is equal to 4. All right, so this one is supposed to be 270. Okay, this one is just a straight line. So we need at x is equal to 2 here. You place your ruler at x is equal to 2. All right, so let me just try to increase so that we can clearly see where our x is equal to 2 at. Okay, so this is our x is equal to 2. You join. Okay, so I'm just going to join, and also this paper is being scanned, so some of these boxes, I don't know, they are shifted a little bit, but that's it. So you just draw them, x is equal to 2, then you move on to x is equal to 4. This is where you're going to have your line. You join these points, you just join them a little bit. Let's just try exactly a little bit like this. All right, so this is our line of x is equal to 4. So I'm going to write the equation x is equal to 4, x is equal to 2. Now with this region, take note, we need a region that is bounded, guys. This is our question, it's bounded by the graph and the x-axis. So it's supposed to be in between. This is your graph here and your x-axis. So which means we are going to take above this x-axis here, above the x-axis, like above the x-axis. So you count the number of boxes. Remember, guys, I told you that the area, you actually count the number of boxes which are in that region. Okay, so that's what you're going to simply have in this case. So I'm just going to have our formula of the area, that is number of boxes, here over 100 times the area of unit square. So this is area of a unit square. All right, so we've got area of unit square, which is number of boxes you calculate in between this graph. All right, so as you can see, this one is actually 100. The whole box, you know that the complete box is 100, so you just write this 100, 100, and you write inside, okay, this is also 100. We also have this one at 3, which is also 100, and you count these boxes. They are around 11, 12, so you count everything, okay? And these ones, you count them properly in this case, okay? So that you've got all the number of boxes properly counted. Then if you are to add everything, we've got 100, this 100, 200, 300, 400, 500. So we're going to have 500 plus the 12 there, plus the 49. So it depends with what you're having, guys, on your graph. Okay, so after adding your values, that's where now we are going to use what? We are going to use the formula. So this is what you're going to use. So here I'm just going to use 561 as an approximate value, but you're supposed to do the exact thing. And this is an estimate value, take note. So I'm just going to have something like 561 over 100 times the area of unit square. What does this part represent? The area of unit square, the square. This is the first square here. Let me erase this part. I'm going to erase the graph everything so that you see what a square is. Okay, this is what a square, the first square that you have here. This is the area of the unit square. The first box that you have got here. All right, so okay, let's get back to our more thing. Okay, the first box that you are given, that is your square. Okay, this one. The first box, that is the area of the unit square. So here you've got 1, here you've got 1. So you multiply 1 times 1, which is 1 square unit. That is the area of the unit square. So you multiply by 1 here. So by doing this, you're going to obtain 5.61 square units. All right, so that was our area, guys, as you can see. So here I've removed that part, remember, so that I just wanted you to see what they call area of the unit square. Okay, so that was it, guys. For this part, we've got everything. Yeah, everything is there. And let's see the other part of the question, which is now on number 8A. So 8A was actually something else which is not part of the graph. Okay, so this one is actually not part of the graph. We are given to solve the equation to show that this equation is going to reduce to that part that we are given. So how am I going to show this? It depends with how you actually want it to be. Someone can combine these fractions together. Someone can remove this by multiplying each and every term by what? By the LCM, which is each and every term multiplied by the LCM, or you can combine the two. So I don't know what was actually best for you. Okay, so this is what we have got. So if you are to add, maybe most of us, that's what you can have. We can add, you can just multiply. I don't know what was best for you. So if you are to add, you are going to have x into 1 minus x as your LCM here. So divide the bracket x into 1 minus x, divide by 1 minus x, it cancels, you remain with x. So it's going to be 2 times x here, which is 2x, all right? Minus, we do the same, x and x, they cancel, so you're going to have minus 4 into 1 minus x. which is equal to 3 over 1. Just write this 3 over 1 as a fraction. So you can actually cross multiply here, and this is a 1, it multiplies this part, the 3 multiplies this part. Okay, so as you can see here, we're multiplying the 1, which means this part is going to remain as it is, 2x minus 4 times 1, which is negative 4, minus 4 times x, which is a positive 4x, which is equal to, the 3 here is going to multiply this bracket here. So it's 3 times this bracket. So it's going to be 3x into 1 minus x. That's what it means here. So you can collect like terms. As you can see, you've got like terms 2x and 4x. So if we add 2 plus 4, that's going to be 6x minus 4, which is equal to 3 times 1. That is 3x. 3 times minus x, that will be plus 3x squared. So it's going to be negative 3x squared because it's a negative there. There's a negative. So it's going to be negative 3x squared. This one. All right. So it's negative 3x squared. This is what you're going to have at the end. Then since this is a quadratic that I formulated, I'm just going to collect these terms to one side of the equation, transpose the negative to the left-hand side so that it can become a positive. So I'm going to have 3x squared. Already I'm having this 6x, so I'm going to start with that one. Then I transpose the 3x again to this side, it's going to be a negative. So I'm going to have negative 3x. Already I was having negative 4, I just rewrite that one as it is. Okay, so that's what you're going to have at the end. And from this part, we can actually add these two, but is subtract 6 minus 3, which is 3. So it's going to be 3x squared plus 3x minus 4, which is equal to 0. All right, so that's what you're going to have. So as you can see, we have shown this equation. That is what we are being asked to show. Then solve the equation, giving your answer correct to 3 significant figures. Once you are given this type of equation, correct to, it means the factorization, forget about it. Think of what? Of the quadratic formula. So you're going to use your quadratic formula here, or you can use the completing the square. All right, so I don't know which method you are best at, but most of you guys, you are used to this quadratic formula. On quadratic formula, make sure you write down your formula properly. Okay, so the formula states that x is equivalent to negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Okay, so from this part, from our equation, this is our a here, the coefficient of x squared, which is our a. So we're going to have our a here, our b, and our c. So this is what you're going to substitute in this formula. So x is equivalent to negative b, which is negative 3, plus or minus the square root of b squared, our b in this case is 3. So it's going to be 3 squared minus 4ac. So our a is 3, remember our a is 3 and our c is negative 4. Just write this in a bracket. Everything has to be affected by 2 times a, which is 2 times our a in this case is 3. So that's what you're going to have. Can simplify everything under the square root sign so that we can be able to simplify to solve this. Okay, so just simplify everything under the square root. We are going to have negative 3 plus or minus the square root of, so there you just need your calculator and multiply everything. You're going to obtain 57 over 2 times 3, which is 6. All right, so from this part, you can separate now your square root, which is x is equivalent to negative 3. Remember, there's plus and minus, so you can start with plus square root of 57 over 6 here, or x is equivalent to minus 3 minus square root of 57 over 6 here. All right, so from your calculator, that's we've got our values here, 0.758, 305, and so on and so on. All right, or x is equal to negative 1.158, so it's going to be 58, 30, and so on and so on. Okay, so now we get back to the degree of accuracy, because here we are given what to use to 3 significant figures. That's what you're given. So you maintain that one. So to 3 significant figures, which means we need 3 whole numbers here, 1, 2, 3. So the 3 cannot change this 8, so it's going to remain like that, which is 0.758. Okay, or here we do the same, but 1 is already a significant figure, so we're going to start counting from this 1. So we put 1, 2, 3. And this 8 is going to change this into a 6. So it's going to be negative 1,6, because it has been changed, this one. So it's going to be negative 1,16. All right, so guys, let us just cross-check this one. What are we getting? Is negative 1,758. That's all. Yeah, negative 1,7. Just cross-check. This is a 7 here. All right, 7, 8. So it's going to be 7, 6 now. 7, 5, 8, and so on and so on. Okay. Okay, I saw this one like a 1. It's a 7. This one. So it's going to be negative 1,76. Yeah, something of this nature. So be very, very careful with your values and so on and so on and so on, guys. But you'll see that it's actually nothing here. Quadratic formula, you just need to apply your formula properly. That is what you actually get in this case. Okay, so let's see the other part of the question. Now we are given the inequalities. That is the part of inequality. So remember your inequalities, guys. Here we are given, write down we are given like the diagram shows unshaded region are defined by the one of the inequalities, this one, which is y is greater than or equal to minus 4. So how am I going to know this is the one of y is greater than or equal to minus 4? Just going to focus here with the y-intercept. Yes, the y-intercept here is at 4. And the gradient is 1, and minus 1. As you can see, this is the gradient. This is the line that has got a gradient 1. We've got 4 here. Remember, increase in y over increase in x. So here we've got negative 4 over positive 4. So it's going to give us a negative 1. So it means this line I'm already given is inequality. This one is there. All right, so let's cross-check this one. There's a vertical line here which passes through 4. This one, there's a vertical line here which passes through 4. So a vertical line, we know that the equation of this line is x is equal to 4. So that's the equation. You start with the equation first. X is equal to 4. Then what about the inequality? According to this side, you can see this is a lesser region, this is a bigger region. So which means we are taking of this nature. Well, because this is the part that is not shaded, this side is one that is not shaded. So our x is going to be less than or equal to 4. Okay, so that is what we have in this case. Okay, we move on to the other line, which means we are now talking of this line that is remaining, which is passing through 4 again. Yes, it's passing through 4 here, but what about on this side? Okay, let's just remove this part. We're talking about this line here, the one that is going to pass through 8 here. As you can see, it's passing through 8. So we need the equation first before talking about the line. We need the equation. So you know that if we can find the gradient, then we can have the equation. So using equation, you can take these 2 points, 0, 4, this point here, which is at 0, 4. Okay, I have the marker here. Okay, let's get back. So you've got 0, 4 here. All right, guys. Let's get back again. That's 0, 4. I don't know what's actually happening with this software. It auto saves after some time, and at that time I'll be recording. So let's hope it doesn't affect. So we have got 0, 4 here and 8, 0. Okay, so these are the points that you're going to have at the end. Now I want you to see what is happening from these 2 points. You can actually use these points for your equation, but I'm going to use the easier way of finding the gradient here. Increase in y over increase in x. So that's my gradient, which is m. Remember I told you guys about finding the gradient where you got, if you're going down, that's a negative. So from 4 to 0 here, that's a negative 4 over increase in x from 0 to 8, which is 8. So it's going to give us a negative half. So that's our gradient. And we know that the equation of a line is given in the form of y is equal to mx plus c. So y is equal to m, which is the gradient, which is half x plus c. C is our y-intercept, which is at 4. So this is the equation of the line, okay? And remember, guys, I told you that you can take the inequality by just looking at the line. As you can see, this line is the one that we are working with here. It's a continuous line, yes, but the region that is shaded is this region. And for a line like this is your greater region, this is the smaller region. So as we are working with this part that is not shaded here, so this is the region, this side. So we are working with what? With a lesser region. So which means y is less than minus half x plus 4. Then we cross-check our line. Is it continuous or not? This one is a continuous line. As you can see, the line is continuous. So if it is a continuous line, you use the equal to. But if it is a broken line, you leave it like that. So this one is going to be less than or equal like that. So that was the inequality, guys. That was the question. To find the other two inequalities, then find the maximum value that we are going to obtain for 3y plus x. Okay, so for you to have this maximum value for 3y plus x, you need to go back to the region that you're given. The answers actually are going to be taken from these, where around the region that is not shaded. This is the region that is not shaded, this one, where your arrow is located. So this is where your answers are going to be taken. Since these are continuous lines, you're going to take this point at 0, 4. You take this point at 4, 0. You take this point here, it's 4, 2. Okay, let's remove this part so that we can clearly see where it is meeting. So this point here is 4 and y is 2. Okay, we've got this part that is disturbing here. Okay, so that is 4 there, and this is 2. So these are the points that you're going to take. These 3 points, you do not take anything in within, because this is for maximum or minimum. So these are the points that you use. So you take the points which are surrounding the region that is not shaded. That is where we have your values. The region that is not shaded, then you take the points which surround that region. Okay, so let's try. It's a trial and error. It's not like you're going to have your answer direct. Okay, so you just list your points. We said 0, 4. So let's just list them down. So you said the first point is 0, 4. Okay, the other point was 4, 0 here. Okay, remember this point is 4, 0 there. Okay, so that's our another point. So we've got 4, 0 here. Then another point, you take all the points that are surrounding the shape, which is 4, 2. That was another point. So we put 4, 2. So these are the only points that you're going to try to use. That is where your answer is going to be taken. We need where we are going to have the maximum value. When we substitute on this expression, the expression is 3y plus x. It means this point, this is x, this is y, this is x, this is y, this is x, this is y. That is what it means. So which point are you going to substitute in place of y and in place of x? Then you get the maximum. But by just looking at it, you are adding this part, you are adding, and definitely, guys, you have to try the last one. Okay, so you try, but the last one definitely is what that's going to give us the answer. Where in this case, y is what? Y is 2. So it's 3 times 2 plus x. X is what? X is 4. So let's multiply 3 times 2. That's 6. 6 plus 4, which is 10. Okay, so you just try. There we said our y in this case. Okay, that's 4, 2. All right, so our y in this case is actual 10. Okay, this is not going to give us a maximum. There is this one. So you see the issue of trying, guys, it's a trial and error. This one is an error that you have to try. So let's use this one 0, 4, because this one is giving us 10. I'm seeing something here. 3y plus x. Okay, so let's use this one when y is equal to 0, and this one cannot give us, yeah, this one 4, 2. Okay, let's just use them. Y is 0, I'm going to see answer 0 here, and x is what? X, sorry, y is not 0, y is the one that is 4 here, all right? Y in this case, that's a 4 here, that's your y, so you're going to write the value of y, which is, in this case, is a 4, okay? And your x in this case is a 0 here. So 3 times 4, that is 12 plus 0, which is 12. So you see, there's a bigger value. Let's see this one, 4, 0 here, 3y plus x. Our y in this case is a 0, this one, so it's 3 times 0 plus x. Our x is 4, so that's 0 plus 4, which is 4. So as you can see, guys, our maximum value is going to be obtained from this one, which gives us 12. So not this one. So it's not about looking the values, it's about the one that is going to give. So you can use to analyze also equations. So our answer in this case is a 12, not 10. So this is the one that gives us our maximum. So you are not trying everything, guys. You are trying from those points that I showed you, which are surrounding the region. These points, you do not take any other point like inside the region to say, I'm going to try this point or this point. Use the points which are surrounding the region that you're given. That's how you simply work out these typical questions. I hope this part is actually clear. We just have to try as much questions as we can. All right, so let's see the other part of the question. It's actually number 9, which is on a vector. So this one is a vector, number 9a. We are given vector v and the modulus. Remember, this represents the modulus, the magnitude, or the length of a line. This one is actually the modulus here, all right? So given that the modulus of v is equal to 17, which means, remember I told you guys the modulus actually means this, the square root of, if you're given the modulus of v, it means the square root of x squared plus y squared, where this is your v, this is your x, and this is your y. So what am I going to do? Since I want two possible values of u, I'm just going to substitute here because I'm given the modulus, and I know that the modulus is equal to the square root of x squared plus y squared, and my x here is 8, so it's 8 squared plus y in this case is u, so it's u squared, is equal to the modulus now that you're given, and you're given that the modulus of v is 17, so this is equal to 17. So what have I done? I formulated an equation where I have to solve for v, for u, sorry. So what am I going to do? Remove the square root. Remember how to remove the square root, you square both sides. So the moment you square these two, they actually neutralize each other. So you're going to be left with 8 squared plus u squared is equal to 17 squared. Okay, 8 squared, that's 64, plus u squared, which is equal to 17 squared, that's 289. So this is 289. So we can actually transpose the 64 to the right hand side, and it's going to be a negative 64. Okay, so we're going to be left here with the u squared is equal to 289 minus 64, that's 225. So this is 225. How do I remove the square? Just like what I did on square root, I'm going to put the square root, okay, both sides. So which means, remember, the square root of any number is a plus or minus. So this is going to give us plus or minus 15. So that's why you see we've got two answers here. So the one is plus 15. Another one, it's a negative 15. That is what it means in this case. All right, so this was direct question. As you can see, let's see the B part. We are given a vector again, but this one is actually a drawn diagram. And from number 9, we are given that in the diagram, xz is P, that is x to z is P, xy is Q, and we are given that yz is a point, so that 3ym is equal to yz. Okay. This is actually a ratio that you're given there, so you have to play around that one. We are going to see it later on where we are going to use it and how to play around that ratio. All right, the first part was to express yz in terms of what? P, in simplest possible, in simplest form. Okay, so what is yz? That is the vector, the route that you're going to take from point y to point z. Okay, this is our y to z. So as you can see, you're going to take the route from y to x. Okay, so this is going to be less. You can even write it here, no problem. Because I'm just so that you can just see what is happening. All right, now let's see what happened now. Guys, this thing of saving whilst class now is the problem. So in this case, we need our yz. All right, so I'm just going to indicate yz in this case, which is equal to, from y to z, that is yx, from y to x. So I'm going to have y to x plus x to z. Okay, so this is going to give us x to z. All right, so according to the direction, take note here, from y to z, we are actually opposing the direction. We are supposed to go this way, and we are opposing, so it's going to be a negative, so it's negative q. And from x to z, we are maintaining the arrow or the direction, so it's going to be a positive p. Okay, so you can even rearrange this as p minus q, just starting with a positive value is still fine. Okay, so that was our yz in this case, which is p minus q or q minus p. All right, so that is your yz here, p minus q. But just even looking at the diagram, you can just take your answer, isn't it? Yeah, you can even take your answer direct by just looking at the diagram. Okay, so that was the first part. Let's move on to next question on the next page. We are now given to express ym. Okay, so we now need the value of ym as simply as possible in terms of p and q. Okay, so where's our ym? Let's cross-check from our diagram where our ym is situated. This is the most important part now, because we have to refer to that ratio that we had from our diagram. Okay, so let's see. Okay, this is our ym. From that ratio that we had, because this is where our ym is situated here. Let me indicate here, 3ym is equal to yz. And previously we calculated yz. This is our yz here. So now we need ym. If you can play around this ratio, if you just divide by 3 here, you can see that ym is equal to what? Yz over 3, which means it's a third of yz. That is what it means. So we're going to have a third of yz in this case. Okay. So that is it according to your vector. So which means we are just going to take a third of yz to find what? Ym. So that is it, guys. We can just have this and substitute our values now. Right. So here we are going to have a third set our ym. Oh, no, it's now too far. It went too far. Okay, so our ym is going to be a third of yz. All right, that's a third of yz, the one that we got, and our yz, remember, it was p minus q, so you substitute that one. Yes, you can just leave it at this stage. Someone can expand this to be a third p minus a third q. Yeah, you can even leave it at that stage, is fine, okay? Then the third part, express xm as simply as possible in terms of p and q. Okay, xm. Now we have got ym and we need xm. Okay, so let's get back to our diagram from x here to m. Since we have this ym, this one, I'm just going to take this from x to y and y to m, just like that. Okay, so that's the route that I'm going to take. So xm, guys, let us just write it here. All right, so xm is equivalent. We said we are going to take from x to y. Okay, that is x to y, then y to m. Okay, so that's xy here. All right, so we are going to have our xy plus our yz. Where am I having yz, guys? This is ym, all right? So this is ym here. So xy, that is the route that you're going to take. Xy is already there on our diagram. If you have to cross-check on our diagram, our xy is already given as what? As p. And this time we are maintaining the arrow, that is, we are maintaining the direction because we are starting from x going to y, so it's going to be a positive q this time. So it will be positive q. All right, that's positive q plus ym. This is your ym that you calculated on this part, and we got 1 over 3p minus 1 over 3q. So you're going to add 1 over 3p minus 1 over 3q. Okay, so you're adding, so the minus is not affected because you're adding here. So let us just collect our like terms. I'm going to start with this part with a p. So I'm going to start by writing p, which is a third p. So this is 1 over 3p. On q here, this is 1q, this one. Okay, so this is 1q. So how do you simplify this? You just subtract from your calculator 1 minus a third from your calculator. Okay, 1 minus 1 over 3 from your calculator. What are we getting? We are getting 2 over 3. So we're going to get 2 over 3 multiplied by vector q. Okay, so this is our xm. So take note, guys, because vector is very be very careful with your answers, because any answer you're going to use it to on the other part. So make sure that your answers are very, very correct. Okay, then let's see. After our xm, we are now given that n is a point that is going to lie on the point xn, so that xn is equal to hxz. Express xn in terms of x. Okay, so the first part is, do we have xz? That is the first thing, because we are given that x is equal to hxz. So remember, h is a scalar, then we need vector xz. If we calculated this vector before, so that is what we need to cross-check. Xz, we never calculated this. We go back to our diagram. Do we have xz? Xz is there on our diagram. That is x to z is vector p. So you're going to take that vector p as it is. All right. So it means this one is h vector p. That is our x what? Our xn. As we can see, guys, it's just a mark. That's why it's just direct like that. All right. So we put our xn. Then the other part, we are given that xm, we are given also that xm is equal to, this is our xm that we have got, okay? Then we are now told from this xm that we have, which is h plus kq, like this one, we are now asked to use the two expressions for xm, okay? Which means there is another xm. This is what we are told. Okay, use the two expressions for xm to find the value of h and the value of k. Where is the other xm? Okay, so let's start by this one that we are already given. I'm just going to write it this side here. All right, so the first xm is this one that we are already given here, that xm is equal to this. So xm is equal to hp plus kq, like this. Okay, this is our first xm. Then we have to cross check on our calculations because we are not told where this xm is. Sometimes they'll tell you on item this, you just take from that item. So we have to cross check, where do we have xm? Xm, we calculated it here. This is where we calculated xm on item 3, and we got our xm, this one, which was a third p plus 2/3 q. So this is what you're going to take on your xm. This is another xm. All right, so equate these two, because already we have got this xm that we wrote here and the one that we calculated previously on our item 3. We got that xm is equivalent to, we said, a third p. So this was a third p plus 2/3 q. That is what we got from that one. So I told you guys, when we are dealing with vectors, if these two vectors are the same, what does it mean? It means this vector p and vector p, as you can see, they are the same. So you equate the scalars, this one that are affecting, that's a scalar, that one that is affecting the vector p, which is h. So h is equal to the scalar of this vector on the other side, which is 1/3. So h is equal to 1/3. Are you seeing that? You move on to q, you remove the vector q, you take the scalar, which is k. So your k is going to be 2/3. So that was it. You've got the value. So this one, we did not need any issue of working out this and that. No. This one was just direct. Okay, this was actually direct on this one, on this question. So this is the value of h and k. Then the other part now is we are given, write down the numerical value of the ratio xn as to nz. Okay, xn as to nz. Actually, when you are dealing with this type of equation, you must have a statement which consists of xn and nz. Where are these actually located? Xn and what? And nz. Okay, let's get back to our diagram. We need xn over nz. Okay, we are going back to our diagram. But before that, we have a statement. Okay, so let's try to reduce so that we can actually locate where there is xn. All right, this is where we are given xn here. We are going to this item. So you locate the item that used the statement that has got xn and so forth. Okay, so I'm going to take this statement on item 2, this one, where we are given that xn is equal to hxz. Remember, we calculated our h this time. So we are saying xn is equal to h, and our h, remember, was 1/3. So h is 1/3 there. All right, so this is where our h is located. Okay, guys, let it save a little bit. All right, so this is where we are having 1/3. It hasn't saved. It hasn't saved. All right, it's fine. So I'm just going to take it this way. Just gonna allow it to save a second. Okay, I think it is saved now. Okay, so this is 1/3. So we've got our xn here, which is 1/3. So you said this is 1/3 vector p, like this one, which is actually 1/3 of what? Of this part that we are given before here, because we're given hxz. So it was 1/3 of xz. So what does this ratio mean? It means your xz is actually having 3 parts from this diagram here. Let's go back to our diagram. We've got our xz. This is your x to z here. We are given the whole of this xz is actually 3 parts. This one, that is what it means. Xz is 3 parts according to the ratio. But our xn is going to have how many parts from there? Our xn is only having 1 part out of these 3 parts of xz. So the 3 represents the total for xz, the 1 for xn. So xn is having 1 part. All right, so that means here, this is our xn with its 1 part. Let's see where our xn is here. So this is our xn with 1 part. But remember, we said the whole of xz is 3 parts. So how many parts are going to be left from n to Z. From N to Z, we are going to be left with two parts. So it's 1 and this one is 2. So it's going to be 1:2. All right, so that's it, guys. 1:2. I'm going the wrong direction. All right, so that will be your xn. So we said xn is one part. That is our xn here is one part, and nz is two part. So it's going to be 1/2. So you answer the question the way you are given the ratio. If it was given like this, find the ratio of xn as to nz like this, it was going to be 1:2. Okay, so it means this is 1 and this is 2. Now we need the ratio of area of triangle xyn as to the area of triangle xyz in simplest form. Okay, so it's xyn as to xyz from the area. So this one we have to use our diagram and see what is happening on our diagram. So take note, it was the ratio of xyn, that is xyn, this one as to xyz. Okay, so for triangle xyn as to triangle xyz. And this is area. I want you to see what is happening with these two triangles here. These two triangles, they are actually on the same base, which is xz. They are on xz here, and they've got the same height, which is xn. So on that type of equation, the ratio of sides, this one becomes the ratio of areas. These are not similar figures, so you use the ratio of sides, okay? So ratio of sides is equal to ratio of sides. If the triangles are not similar and they share the same base, they are on the same base and they share the same height, the ratio of sides will be the answer. So this is 3 parts here. This is 3 parts, guys. Why? Because we are referring to the whole of xz, the triangle xyz. So from x to z is 3 parts, remember, but xn is 1 part. So you take the ratio of sides. So it's 1:2, 1:3. All right, so that's actually how you deal with these typical questions. So you're supposed to know also your ratio from normal ratio, not from vector, because this one is just an application from your vector, but we are supposed to take this from our normal questions. Okay, then we move on to the transformation part, which is actually on question 10. This is transformation, and we are given the fit, that is the diagram where we're going to be constructing, where we are going to have our diagrams here. So I think everything is pretty clear here. So let us see what we are given on this question. Okay, so let's just here, okay, let's just diagram. Okay, this is right. Okay, so the first part here we are given, guys, make sure that your information is completely, you completely understand the information that you're given. That is the best thing that you have. So we are given triangle LMN. LMN has vertices at L3, 1, M2, 2, and N, 0, 1. So what we need is to mark the points that we're given. So we've got L, which is 3, 1, because we want to draw this triangle. So 3, 1 is actually in between. Here, according to scale, I want us to understand what our scale. Let me just try to reduce my pen a little bit. All right. So according to our scale here, we are going to see that each part here is actually represented by 2, 4, 6, because we have got 0,2, because of 2, 4, 6. So which means each box is going to be 0,2, 0,4, 0,6, 0,8, 1, 1,2, 1,4, 1,6, 1,8, 2. So each box is 0,2. So which means in this case, the point that we need, which is 3, 1 is going to be in between according to what we're given. Okay, is it going to be, okay, 3, 1 here. Okay, so we need 3 in between 2 and 4, then 1 in between 0 and 2. So that's 3 somewhere, 1, 2, 3, 4, 5, and we count 5 boxes up. That is, this is 3 here. So we put 1, 2, 3, 4, 5 somewhere here. That's where you're going to have your 5th box there. So you just have to join that point. All right. So that's what you're going to have, our 3, 5, and we just call this point L. Okay. Then we move on to back here. Let's see M, which is 2, 2. Okay. So this one is direct. When X is 2, Y is 2. This point, which is our M. So it's 2, 2 somewhere here. So this is our M. So remember, it's L, M, N, and the last point is N. Let's see what we are given, and our point N, which is 0, 1. Okay, so our N in this case is 0, 1. That is 0 here, then 1. We count 1, 2, 3, 4, 5. In between, you just count 5 boxes. That's where our 1 is. Okay, so this is our N from M to N. So all we need here is to join these points that we are given. Okay, so let me just write my M here. So join the points so that we can complete the diagram that we are given in this case. All right, here's our ruler now. We need this ruler here. All right, there. I hope there are now not many now. You see, it wasn't responding. Okay, so just join L and M. This one you join direct to that point. So it's going to be N direct to M here. And we do the same from these points. That is M to N. So let us just try to rotate this part here so that we can join. So we are going to join L, M, and N in this case. All right, so these are the 2 points that we are going to have. So guys, as you can see, this actually takes us a lot of time to have this, but that's what you're going to have at the end. Okay, somewhere here, I need to maybe a little bit this side, and now it removes this side now. All right, but somewhere, no, here. Let's join again. So guys, I hope you understand what is happening. It's only that this part, you have to be very, very accurate. All right, so you just join your points. You do the same, just rotate your points, they join them together. All right, so you've got L and M together, so somewhere there. All right, so you just join. So make sure they are exactly at the point. Yes, not like exact, but it's supposed to be directly going to the M there, direct to the N, like that. So that is our triangle. And okay, we'll see what we've got from the next part. From the next part, that is what are we given? We are now given that triangle LMN is mapped on triangle L1, M1 by a reflection in the line of y is equal to 1. Draw and label triangle L1, M1, N1. Okay, so what we need is to have first the line of y is equal to 1. Okay, so let's get back here. Draw the line of y is equal to 1. So this line actually passes through y, where y is equal to 1 here. We say, remember I said this is where our 1 is. So we have to draw a line, a horizontal line that is for y is equal to 1. Okay, so let's just insert our ruler here so that we can draw our line. All right, so this is it. We draw on this line of y is equal to 1. Just make sure that you draw a continuous line, right, like this one. Okay, so that's our line that we are having, and you name the equation of the line. So in this case, this is the line of y is equal to what? Y is equal to 1. So the question is for us to reflect this triangle. So let us get back to our question so that we can reflect this triangle in this line. So we're given each point is supposed to be reflected in this case. All right, so that means in this case we need L1 is going to move from where it was, M1 it moved the same as N1 from the original points. All right, so from the original points, L and M and N, this point here, this one is actually on the mirror line, which is y is equal to 1. This point L that we are having, okay, just a little bit, the L that we are having is directly on the mirror line. And also with the point N, it's also on the mirror line. So these two, they are not going to move anywhere. But we are going to have this, our M now moved. So what is going to happen? M is going to move to the mirror line. As you can see, we have got one distance from M to the mirror line here. There's just 1 unit. So it moves down. So it's 1 to this point is 1. That it moves 1 box going downwards to 2. That's a reflection because this one is a horizontal line. So it moves 1 unit to this point, 1 box, then it goes down 1 box. Okay, so which means we shall have a reflection of M at this point 2 which is our M1. So the L is not going anywhere, so it will remain there. That is where our L1, the N is not going anywhere, so it is going to remain there. Okay, then from there, you join. So this, guys, you just use your ruler. I'm just going to use a hand here because it's not going to take us time, guys. Okay, but that is what you have. Make sure that you join using your ruler. That was it, guys. You've got your reflection of the line of the triangle in the line of y is equal to 1. All right, so that is it. Let's see the other question. On C, we are given that triangle LMN is now mapped onto L2, triangle L2, M2, N2 by a rotation through 180 degrees about -1, 0. Okay. Remember, guys, I told you that when you're dealing with rotation, you can take advantage of using matrices, okay? Remember, your matrices, this is rotation about 180 degrees, where we know that the matrix is going to be given by -1, 0, 0, -1. This is the matrix for rotation, so you need to know your matrices, all the matrices. So for rotation, 90 degrees, 180 degrees, I mean, it's going to be like this. Remember, we are taking from this Cartesian plane. We've got 1, 0 here, -1, 0 here, 0, 1 here, and 0, -1. So this point, if it rotates 180 degrees, it is going to be seen here, which is -1, 0. If this point in the y is rotated 180 degrees, it is going to be seen at 0, -1. So that's how you take your points from what? From the Cartesian plane, which is from the unity square. Remember the concept of the unity square? I actually talked about this earlier on. So that's our matrix. But here we are given the center now, which is not 0, 0. So remember the concept, when the center is not 0, 0, you're supposed to subtract the center first. So we are going to subtract our center so that we can use the matrix, since matrix times object is equal to image. So subtract center from the coordinates of the object, which is from L, M, N. Remember, this is your L, which is 3, 1. So our L here is 3, 1. Our M is 2, 2. Our N is 0, 1. Okay, so from this, subtract your center. Your center is -1, 0. So you're going to subtract -1, 0 like that. All right. So that means if we are to simplify this, we just subtract the normal way, not like you are dealing with matrices, okay? Just to say this L subtract this point, M subtract this point, just like that. Okay, so it's 3 minus, which is a plus, so it's going to give us a 4, 0. This is 1 minus a 0 there, which is a 1. Okay, then it's 2 minus, which is a plus, so 2 plus 1, which is 3. 2 minus 0 here, that's a 2. We move on to 0 here, it's 0 minus, it's a plus, so it's going to give us 1. 1 minus 0, which is a 1. Okay, so that's what you're going to have after subtracting. Then now you can use your matrix. Remember, after this, that's where you can use our matrix. We're going to take this matrix now to multiply what we got here. So we're going to multiply by our matrix now using matrix multiplication, row by column. So it's going to be row by column here. That's -1 times 4, which is -4. 0 times 1, that's a 0, so it's not going to add anything. Move on to this column. -1 times 3, that's -3. 0 times 2, that's a 0, so we're not going to add anything. -1 times -1, that's -1 on this row, on this column here. 0 times 1, that's a 0, so it's not going to give us anything there. All right, the same thing, we move on to this row, first column. So that's 0 times 4, which is a 0, that's nothing there. So we put -1 and 1, which is -1. 0 again with this column, it's 0 and 3, there's nothing. -1 and 2, which is -2. 0 and 1, it's nothing there. So -1 times 1 is -1. Okay. We subtracted our center, then we used our matrix now to multiply. It means now we have the image. But this image, I want you to take note about this image. This is the image which we got after subtracting the center. So what are we going to do now? We are going back to the center that we subtracted here. Remember, we had to subtract our center. Let me indicate here. Okay, let me take our marker here. So remember what we did on this point, we had to subtract y. Okay, I'm placing, sorry, I was placing a mouse in place of what? On place of this board, that is why it was. Okay, so that's the center that we subtracted. Now what are we going to do? we are saying this is our image, but this image is not of center 0, 0, not of what? Of center, not of -1, 0, the center that we had. So this one is the image, but is not of this center. So what are we going to do to have the image which corresponds with this center? We have to add back that center that we had. So add back the center. All right, so we are going to take our center, then we add it back here. So what was the center? The center was -1, 0. So on your answer, add that center again. So now it becomes the exact image. So -4, -1, -3, -2, -1, -1. We add back our center, which is -1, 0. So by doing this, we now have the exact image, which is L2, M2, N2. Remember, it was LMN, LMN. So it's going to be L2 because this is the second image. Okay, so what are we going to have at the end? Let us add. We're going to add here -4 plus -1, that's -5. -3 plus -1 is going to be -3 -1, which is -4. -1 plus -1, that's -2. -1 plus 0 here, that's -1. -2 plus 0 here, that's -2. -1 plus 0 here, that's -1. So that is your image, but you can just write it in point form so that you just to show that you understand, guys, what you're talking about. So this is L2, a point which is -5, -1. So this is the point that you're going to mark on your graph. We move on to the second point, -4, -2, which is M2. So this is M2, -4, -2. And the last one, which is our N2. So our N2 is going to be -2, -1, like this. All right, so these are the points that we are given. With these points, we are going to draw them now. Okay, this will be our triangle that we are asked to draw here, which is our triangle L2, M2, N2. So let us get back with these points that we just got here, which is these points that we just got here. Let us take them to our image. 5 minus 1, that is our L2. Remember the first point, it's 5 minus, is it 5 or -5? Let us cross check. It's -5, -1, all right? So that's -5, -1, which is -5 here, -5 in between, -4 and -6, 1, 2, 3, 4, 5 here, and -1, we count back 1, 2, 3, 4, 5. So it's somewhere here in between here, because remember your scale, we are saying 2, 4, 6. So -5, -1, that's where we are going to have our L2. The first point, it was L2. So this is our L2. Okay, remember our M2 was -4, -2. So we need -4, -2 this time. All right, so this is where we're going to have our X being -4 and our Y being -2. That is at this point here. So this is our M2. And our N2, remember it was -2, -1. So -2, -1 straight at -1 under -2 here. That is where you're going to have it. Okay, so as usual, guys, you take a ruler, join your points, but in this case, I'm just going to join select because this ruler is taking us a lot of time, guys. Okay, so you take a ruler, you join your points direct. Okay, make sure that you join properly your points there. That is what you're going to have at the end. All right, so this will be your triangle, which is the image. So take note, it's a rotation. So you can use matrices. Know your matrices, all your matrices from 90 degrees clockwise, 90 degrees anti-clockwise, 270 degrees clockwise and anti-clockwise, then also 180 and 360. So that's what you just needed. So remember, this is our M2. So let's just indicate here. This is M2. All right, it's now saving again. But you just need to indicate your points, all of them, guys, all right, so that everything becomes clear. So you said this is our N2 here. So your points are all there. And let's check the other question. What are we given here? All right, that is the D part. All right, let's check our D here. So on the D part, we are now given triangle L3, M3 is the image of LMN under the matrix represented by, under the transformation represented by the matrix. Take note, we are given the matrix again. Draw and label the triangle. So just like what we did previously, guys, we need our matrix. Here we do not have center, we do not have anything. We just take our matrix direct. Matrix times what? Object should give us the image. So that is what we have. Matrix times object must give us the image. So the matrix is the one that we are given here. So we're going to take our matrix, the one that we are given, minus 2, 0, 0, 1. Okay, so it's minus 2. Minus 2, 0, 0, 1. That is our matrix times the object. The object, you go back to those L, M, N, those points that we had to take your M, your L, your M, your N. Okay, so remember our L was 3, 1. So that's 3, 1. Our M was 2, 2. Our N was 0, 1. So you take those points, just the one that we used back, and we do our matrix multiplication row by column. We did this one previously, guys. Minus 2 and 3. That's minus 6 plus 0 times 1, that's a 0 here, minus 2, and this row, and this column, so it's minus 2, and 2, that is negative 4, 0 times 2, that's a 0 here, we're done. We move on to this column, negative 2 times 0 here, that's a 0, 0 times 0, that's a 0, so you're going to just get a 0 here. Then we are done with this, we move on to this row now, back to the first column, so it's 0 times 3, that's a 0 here. 1 times 1, which is a 1. So if we add, we are going to obtain a 1 here. We move on to this column, still on the same row. So it's 0 times 2, which is a 0 here, plus 1 times 2, which is a 2. As you can see, you're going to obtain a 2 in this case. Okay, this will be 2. And now we move on to this row and the last column, which is 0 times 0 here, that's a 0 plus 1 times 1, which is a 1. So we're going to obtain 1. So this is the image that you're going to have, which means we've got our L3. Remember, this time is now L3, M3, and 3. So just write this as points L3. That's negative 6, 1. M3, which is negative 4, 2. N3, which is 0, 1. Okay, so these are the points that you're going to mark and draw the diagram at the end. Okay, so let's get back to our graph. Mark L3, which is negative, let's get back to, okay, this is a positive, this one. Okay, so let's see, what is it going to look like? How is it going to look like? Okay, sorry for that, guys. It's now taking us some time here. So actually, I think we are going to just work with these questions separately, guys. Working with these 4 papers, as you can see, guys, it's a lot. It's actually a lot that you're going to have. So I think the best, we shall just work with different questions, but try to do as much as we can, much questions, okay, that can actually help us. Okay, let me reduce a little bit. Here, minus 6 and 1. So we've got minus 6 and 1 here. Remember, our 1 is somewhere here. That is where our 1 is. Let me change the mark here. Draw different shapes. Okay, it's fine. So this is minus 6, 1. At this point, you mark your point. You say this is our L3. M3 was minus 4, 2. Okay, this was minus 4, 2, somewhere here. That's minus 4, 2. That's our M3. Okay, so we've got M3. Then our N3 was 0, 1. So 0, 1 here, we are going back to the N1 that we had, the same N, the same N1. So it's repeating there. So that's where your N3 is. Okay, so this is where it is going to be a 0, 1. Then you join. So as you can see already, we've got a straight line here. So I'm just going to join from this point, guys. Make sure that you use your ruler here. I think I talked about this issue, that I'm just going to use this part since that ruler is taking us a lot of time. So you join these points together. Then from M3 to L to N3, you do the same. You join your points like that. Okay, so you're going to have your triangle. That is this triangle, which is the image under that matrix that we're given. All right. So that was the question. And back on the other question, let's see now what are we given to have. Describe fully the single transformation P, which maps triangle LMN onto L3, M3, N3. All right. So this is what you're going to see. For you to describe this transformation, you're going to simply use this matrix that you're given because you know your matrices, guys. So which matrix is this one? You can see this one is the part that we have from your hook. Remember from your hook there, this one. We now had this as a constant. So we're just having this one now, something of this nature like that. So remember, it can be look. If we look it properly, we can use the look part, this look part, if it is like that. Okay, so this one matrix are actually for a stretch. Okay, so this is stretch. Make sure that you watch those videos of stretch and so forth. Okay, so this is actually a stretch. So to describe, you're not describing it is a one-way stretch. Since here we are not having anything, we are having a 1. That is the invariant line, this one, 0, 1. For the y-axis, this is your x, this is your y. So when there is a 0, 1, it's x-axis or y-axis invariant, this one. So this one is for y-axis invariant, and this one is for x-axis invariant. Okay, so it is a one-way stretch. It is a one-way stretch, this one. So we're going to have one-way stretch. Y-axis invariant, because we are covering this part for y, and y01 is going to be y-axis invariant. So it's y-axis invariant. And the stretch factor, the k part, this one is your stretch factor, which means our stretch factor here is -2. So we're going to have stretch factor of -2. So know your matrices, guys. Know your matrices of transformation. This is what is very, very important. All those look, hook, and so forth. I think I tried to mention them so that you can easily know this one is for. Okay, so you just need to memorize. I don't know how you're going to memorize them, but you just need to know your matrices. Once you know these matrices, it's going to be easier for you now to just describe, because they can give you a matrix like this one, and you describe from the matrix format that you'll be given. All right, so that's actually what we had from this question. So we shall just look at the other part of the paper, which is the other question. Let's see what we are given. So this is the 10 that we had drawn everything. Then now let's move on to the other one. The other question is we are given, okay, this is statistics. Number 11, the marks of 80 students in a mathematics test are shown in the table. So these are the marks, and we're asked to estimate the mean mark of the students in the test. Okay, so mean, guys, remember mean, you have to find the class centers in this case, then you multiply each by the frequency. Okay, so you need the class center, and the class center, we said we just add the lower class and the upper class together, they divide by 2, 0 plus 20, divide by 2, which is a 10. That is your class center. So each class you have to find is what is class center. You multiply to the what? To the frequency. That will be the mean in this case. Okay, so the mean value is going to be the class center for the first one. We said is 10 times the frequency. What is the frequency from the first class? From the first class, our frequency is 0 there, so there's nothing that is going to come out here. So we're going to multiply by 0. Okay, so that is class center times the frequency. So this one is a 0 here. Plus, we move on to the second class, which is of 20 to 30. Okay, we are now at this class here of 20 to 30. You do the same. Add the values 20 plus 30 divided by 2. So if we add your 20 plus 30 divided by 2, you're going to obtain something like 25 from this. Okay, so this will be 25 and so on and so on. So that's what you did. You do, then you multiply by the frequency, which is 5. So this one is 25 times 5. All right, so you're going to have plus 25 times 5. All right, so I want you to do the same. From 30 to 40 is going to be 35. So 35 times the frequency, which is 19. You do the same on this one. You add 40 plus 50 divided by 2, that is 45 times 18, which is the frequency. Here is 18 plus 50 to 60. You're going to add, which is 110 divided by 2, which is 55 times 16. So you multiply by the corresponding frequency, which is 16. You do the same 60 and 70, which is going to give you 65. So it's 65 times the frequency, which is 14. All right, so it started to save again. All right, so let's see how it's gonna take. Guys, because we need this part. Okay, so we say this is going to be 65 versus 14. We are still at 14. Okay, so let's hope it's gonna take us here. That's a 14. Plus we have got this 70 to 80. So if you add 7 and 8, you divide by 2. That's going to be 75 times 4. So this is 75 times 4. plus we move on to the other class and so on until the last class. All right, so the other class is going to be here, this one 80 to 90, you do the same, is 85 there, times 2, plus we move on, that's 100, which is 95, so it's going to be 95 times 2. So that's what you're going to have at the end. So all this part over the total frequency, all right? So after we have added everything, you divide by the total frequency, which is the number of students who are there. Are we given? We are given that there are 80 students in this case, so you divide by 80. All right, so that's what you're going to do in this case. You divide by 80. All right, so over 80, that is your mean. So you can add everything, combine, calculators do this. We are going to obtain something like 4,050 over 80. Then if you divide properly, it's going to give you something like 50,625. All right, so that is what we are going to have. So make sure that you apply this calculation, add everything properly, calculate each, then you add them. That is it. Okay, so that is what we just did for the mean. It's an estimate mean. You're just working from there, and there's no, I think it was just direct. Okay, so mean, that's how you calculate it. Then from this part, we are now given a continuation from what the distribution is an incomplete cumulative frequency. So these are cumulative frequencies that we are given. Now we are asked to calculate the value of Q. So how do you find the cumulative frequency? Remember, these cumulative frequencies, we found them by adding the frequencies here. All right, this was our frequency table. This one was our frequency table. So actually what we did, we're adding this. We started with a 0 here. So that is how we obtained your cumulative frequency. You started with a 0 here. Then you add 0 plus 5, which is 5. 5 plus 19, which is 24, and so on. So you were adding this term to this term. So that's how you simply got these values. So it means I can even start from the last one, subtracting the values, so that I'll see what was the relationship was we're adding each term. So how are we going to find the value of Q? I just know that I added here 75 plus the number that I had, then I obtained Q from the class that I'm having this case. So we can cross-check from the class of 90, this one, which has got 78. So which class of 90? This is the class that has got 90. So here I've got 78 at this class here. So what happened for me to obtain the previous value? I'm going to subtract, okay? So that is what you're going to have, which is 78 minus 2, because your 78 is at class of 90 here. So for you to obtain this, it was actually as a result of adding 40. See, for this one, the number that we had here to this 4, then you obtain 78. So to obtain that value that you have at this point, you're just going to subtract 78 minus 2, which is what? 76. So it means in this case, it was at 76. So if you add 76 plus 2, that's 78. 78 plus 2, which is 80, which is this one that we have at the end. So this is how you actually got these values. So if you have to cross-check, the last value has to be at 80. Let's see if it is the one that we are having. All right, which is here at 80. As we can see, that's where our last value is at 80 there. So actually that is what we're given, and we just need to work on much questions, guys, as you can see. Okay, then draw the cumulative frequency curve to illustrate this information. So we are given on page 27, is what the part of cumulative frequency. So what do you use now? You use the cumulative frequency table. So already on your cumulative frequency table, I want us to see and analyze what you're given. These marks that we are given, they have already taken the upper classes. Remember what you used to draw your cumulative frequency. I told you that you use upper classes versus the cumulative frequencies. So these are the upper classes. Already we are given upper classes 20, 30, these ones, and the corresponding cumulative frequency. Okay, if you have to cross-check back on our diagram, this is 20, 30, 40, 50, 60. Which are these numbers that are being given here? So these are the upper classes that we are given. So take note on that one, that you are already given the upper classes here, 20, 30, 40. Okay, so we are just going to use this table direct. All right, so using this table direct, let us get to our diagram and see the scale and everything. Mark your points. Remember, this one is going to give us a smooth straight S from this part if you go join properly. All right, so let's start with the first point. We are given here, we mark this 20, which is your upper class, okay? This is the, because we said you are using upper classes, so you mark where there is 20 versus 0, okay? So it's 20 versus 0 here, that's 20 versus 0 here. You just mark your point, that's 20, 0. And take note, each box here is representing 2, 4, 6. Like we're having 2, 4, 6, 8, 10, 12, 14, up to 20. So each box is 2, not 0.2, but 2 direct. Okay. So let's see the other class that we have got. Okay, so this is 30 versus 5. So this is 30 versus 5. Okay, so we're going back and mark where we've got 30 and what and 5. So this is 30 in between 20 and what? 20 and the 50 and 5. So we're going to calculate 1, 2, 3, 4, 5. That is a 30. So remember we said each box is 2. So we're going to have 2, 4, 6. So 5 is in between 4 and 6. So you just mark a box in between, not at the point, but just in between, okay? So that's where you are going to have your point there in between 6 and 4. So 4 and 6, okay? So that's it, 30 and 5. Then we move on to the other point, which is 40 versus 24. So this is 40 versus 24. So let's get it 40 here, 20. This is 20. Remember, each box is 2. So this is 20, 22, 24. So this is 20 versus 4 on that line, direct on that line. We just mark our points. So we've got 40 versus 24. 50 versus 42. So it's 50 versus 42. I hope I didn't go back. Guys. I just hope I didn't get back to the other page. Okay, because here I'm seeing, okay, so we said here I was, okay, we need 50 and what, 42. So this is 50 and 42. All right, so 50 is in between. So 42, okay, this is 40 here. So let's just say 50 is in between 1, 2, 3, 4, 5. This is our 50. Then 42, after 40, we just count to one box, because said one box represents 2, so this is 42. So that is our 50 versus 42 there. You just mark your points, guys, until the last point. Then just join those ones. That's a cumulative frequency, actually. So that's 60 and 58. So we've got 60 and 58 in this. All right, so 60 and what and 58. Let us just see. 60 here and 58 is just one box before 60, because remember each box is 2. This is 60, just one box before. So that would be your 58. And the other one was 70 versus 72. If you cross-checked well there, it was 70 and 72. So we just need 70 in between 60 and 80. That's where our 70 is. Somewhere here, 1, 2, 3, 4, 5. And we've got 1, 2, 3, 4, 5, which is at that's so 1, 2, 3, 4, 5. Then we've got our 70, and we need 72. So it's just going to be 6 boxes from what? 6 boxes from 60. That would be our 72. And 80 was versus 76. So it's 80 versus 76. Remember, this is 80. This is 78. 76 is just 2 boxes before 80. 2 boxes before 80. And we have got 90 versus 78. 90 is in between 80 and 100. So we've got 1, 2, 3, 4, 5 somewhere here, because we need 1 box below. All right, we just need 1 box below here. So this thing, guys, is now getting out of control. Let's just see if we are going to win for this person. I'm just going to see. All right, so we are going to have our 90s somewhere here. All right, that's 1, 2, 3, 4, 5 somewhere here. Okay, so that's our 90 here versus 78. And the last one was 100 versus 80. So this is 100 versus 80 at this point. All right, so that's what we have. And you just need to join a smooth curve from the points that you'll be given. Just make sure that you join the points. You formulate a smooth curve. So that's an ogive or a cumulative frequency. So a cumulative frequency is referred to as an ogive. So they can give you this one as an ogive. So you just know that it's one graph. Okay, it's just different names, but it's actually representing the same graph. Okay, so that's it, guys. You just have to join those points properly so that you produce something that is smooth and not crossing. Yeah, these points, guys, I don't know. How am I going to actually, I now erase the point that I'm supposed to be working with here. Now erase that point, but yeah, just make sure that you've got a smooth curve. Okay, so something like this, that's what you're going to have as your cumulative frequency. All you need is that your points, they are correctly allocated and distributed across the diagram. That's what you needed. Yeah, that's your cumulative frequency, guys. Let's see the other question. What is it now about from this information, or from the cumulative frequency, because we have drawn our graph here? Then showing your method clearly, you on your graph, use the graph to estimate the median. Okay, so median, remember that median is half of the distribution. That is your median. Okay, so we are going to have half of the distribution from that graph that we are given. So the distribution, what is the distribution? Remember, your total cumulative frequency was at 80. It corresponds with the total cumulative, which is at 8, even from your table there. So this is your Q2, which is the median, okay, which is half of the distribution. So it's going to be half of n plus 1 in this case, all right, which is where we are going to have our median value in this case. Okay, so if we are given like this one, we're giving direct a 100 in this case, so you can even half of n. Still, it was you're given already an even number here, so half of n, which is at 50, half of our n, okay, which is at 50. Or if you use half of 100 plus 1, which is going to be at 50,5. Okay, so where we have got our middle value, which is at 50 in between, that is 1, 2, 3, 4, 5. That is where we are going to have our 50. Take note, this is not going to give you the answer. This is the position where your answer is. So at 50 there, you just draw a broken line from that 50 using your ruler straight to the graph. Okay, so you draw a broken line to the graph here. Where it meets with the graph, then down to the x-axis. Okay, so you mark your points with the ruler down to the x-axis. Where it meets the x-axis, that's where your answer is going to be located. Okay, so the value, okay, something somewhere, so I don't know according to your graph where you're actually having. So it is affected also by the smoothness of the graph and this and that. So you know the concept. Okay, so but on this one is going to be 42, 44, 46, 48, 50, 52, 54. Yeah, which is 55, somewhere around 55 there. That was our median value. So you take that one from what? From your graph. Okay, so that one you just work from your graph and you draw the broken line straight to the horizontal. Then you can actually have what? You can actually have your values in this case. Okay, so let's see the other part. The number of students whose mark were more than 45% but less than 75. So more than 45 but less than 75. So we have to use our graph here. More than 45. We have to use the max now. We have to go back to the max, which is more than 45. Let's see where our more than 45 is. That's how you simply work out this part. So more than 45 is in between 45. It's actually 1, 2, 3, 4, 5. This is your 50. Remember, each box is 2. Guys, each box is 2. So this is not actually 55 because it's 50. Because it's 1, 2, 3, 4, 5. This is our 50, 52, 51, 55. Yes, fine. So 45 is just 2 boxes, 42, 44, 45. So in between here, that's where you're going to have. So this time you start from what? From the bottom here, going up. Okay, so from the bottom going up, where it meets with the graph. Okay, straight again using your ruler to the what? To the vertical axis here, to the y-axis. You are going to have your answer at this point. So where that point reaches, and that's where you are going to have your answer, which is going to be something like 1, 2, 3, 4, 5, which is 30 something there, 32, whatever that you're going to have there. So you take the answer that is going to appear there. You do the same, that is your 45. So you're given it's 45 to 75. So you take back the other one that you are actually given. on that end, and you subtract those differences because it's less than, more than, but less than 75. So, and this one is taken from the graph. Okay, so your 75 is 70, then 75, remember this is 70 in between. I've got 1, 2, 3, 4, 5 here. That's our 70, 72, 74. 75 is actually in between. So all you need is to join straight to the graph, just like what we did from the previous part. So this one, make sure that you use your ruler, guys, straight to the graph. Where it meets with the graph here, you join straight again to the horizontal, to your vertical part here, which is the y-axis. Then you're going to have your resultant there. So this is maybe 78, 76, 77, something like 77 there. So the difference between these two, these are the number of learners that you are working with. So take note, you need the difference, not the marks. So the learners, these are the ones which are here. The marks, these are the ones that are here, which are using what? Which are using the upper classes. So that's actually how these questions are be like. So all you need is to work from more questions and revise from more questions. I think that way it can be much, much better.